All right, so today is the day where I'm going to go through my museum heist puzzle hunt and solve the whole thing, hopefully. I did make all of these puzzles quite a few months ago, so some of them especially. So hopefully I can remember how to solve them all. I'm also going to include in the description below the passwords for each of the puzzles. So if you weren't able to figure out a password and you want to just solve the puzzles, you can just instead of watching me solve them, if you don't want the spoilers, you can go check those passwords and open up the puzzles and solve them, or you can just watch me solve them, whatever you want to do. That's the plan for today. I don't know how long this is going to take. Um, so this might be a really long video. I guess we'll see. It's possible I'll split it into a couple if it's too long, but either way, I'll have the timestamps in the description as well, where you can skip ahead to different parts of it if you want to. So without further ado, let's get into it. So this is, let's see. So we should start with the letter, I suppose. Let's see. I can put that on the screen here. Okay, so the letter. So there's not too much to see in here. This is mostly just kind of storyline, flavor text stuff. So we're supposed to be breaking into a museum. There's a priceless trophy that was stolen. Um, excuse me. It's in the inner room in the special collection. Okay. We're supposed to gain access to the room, cover up any artist tools we need to use, and then send a photo of as proof. Okay, and then there's this link down here. And so if you go to that link, what you'll find is a Dropbox folder. And there are a few things in this folder here. Let's see. Okay, so there's this Dropbox folder with lots of files. Now, if you just choose a random file, it says the file is password protected. So the idea is this is sort of like if you were breaking into an actual museum, there would be locks on the doors, presumably. And so, to get the combination to get into the room, you need to have the password. And so, if you can try a few things, you'll notice most of them are password protected. You'll also notice over here you can't see a preview of it if it's password protected. But I mean, the entrance seems like the logical place to start, right? If you're breaking into a museum. So the museum entrance is right here, and you know this is clearly just a normal Sudoku here, a classic Sudoku. There's some extra symbols. There's this looks like the scream, and there's a house up here, and there's this stuff at the top. But um, you'll also find at the bottom of every puzzle there's these links down here where you can go to an online version. So we are going to go to the online version of the classic, and I'm gonna go let my dog outside quick before I continue this one. All right, so classic Sudoku. This one's first. Now, there's gonna be a lot of X-wings cropping up in here if I remember correctly, but it's been a little while since I've solved this one, so we'll see how this goes. Classic Sudoku is kind of a weakness of mine, but let's see. The eight's here. Put an 8 over here, and that 8 gives us the 8. Now we can put an 8 over here because of that one. Puts 8's up there. 8's in here. Now 8 up here can't be in this one. It also can't be in there. So 8 gets limited to row 2, which then means, yeah, there has to be an 8 here because of just normal stuff here. There's also an 8 in there, but I'm not going to pencil mark that one. Now, I think we might be able to do the same kind of thing. Right, 5 can't be in here, and it also can't be in column 5 because of that. So there's a 5 in here. It's a 5 up there, but we don't have another 5, so we can't do that quite as well. The 1 here can't be in that, so it can't be in column 1, which gives us a 4, 5, 9 triple. We can reduce some of the digits because of that. On this side, we don't quite have the same thing. The 7 can't be in here, so it goes in one of those. But this also can't be 1 or 3. So this can't be, this cell right here can't be 1 or 3 because of these two. Can't be 2, 4, 5. Can't be 7, 8, or 9. It has to be a 6. Which gives us 1, 3, 7 over here. And this can't be 1 or 3. Hold on, I gotta pause. My wife's calling me. Okay, I'm back. So, let's see. We had the 1, 3. Yeah, so we have a 1, 3 pair there. Now, X-wings are a little tricky to spot sometimes, but if you get stuck, it's a good thing to look for. I think I'm trying to see if there might be something else we can do before we get to the X-wing, but I'm not seeing. Oh, sevens, sevens. Look at sevens. These sevens. Put a 7 there. There's sevens here. Ah, this is a 7-8 pair. It works the same way. So the 8, I should have seen that earlier. The 7 and the 8 both rule out these, and these 7 and 8 rule out those. So that's a 7-8 pair. 7 sevens. That puts a 7 down here. There we go. Now, I know there's some wings. The things to look for X-wings are, like these 3s here. Both rule out 3s, in columns 4, 5, and 6. So when you get a digit in a box, and then the same 3 over here is also ruling out column 4. And so when you get something like that, you're ruling out a lot of options just with a couple of digits. These 2 3s rule out all those. These 2 3s rule out all those. And so we also have this 1-3 pair over here, right? So we also can't have a 3 in column 9. And so where can we put a 3 in row 1 and row 9? The only options are these. And so what that tells us is, since that's the only place we can put a 3 in row 1 and row 9, we can't have a 3 anywhere else in those 2 columns, because you're going to have 3s either in these or in these. So you can't put a 3 in one of those. So just to show what that does, I'm going to fill in the options here. 1, 2, 3, and 6. Okay. This one can't be 3 or 1, but otherwise those are our options. So what it does is it removes a 3 from that cell, which doesn't seem super helpful, and maybe it's not going to be, but I think we can do the same thing with 9s. You'll notice we have 9s in both those boxes as well, and a 9 over here, and then we have a 9 in our 4, 5, 9 triple over here, so these can't be 9s, and so these are your only options for 9s. Now, again, I'm going to fill in the options for the columns just so we kind of can remove the other ones. So these can't be 5s. This one can't be 9. This can't be 5. Okay, so what it's going to do is it's going to remove a 9 from that cell. And then over here, 1, 2, 4, 5, 6, 9. These can't be 5, 4, 9. None of these can be 1s because the 1 in the box. This can't be 9. 2 or 6, 5. Okay. So it's going to remove 9s from both of those. And now, what else can we do? Oh, this can't be 6. There's a 6 in the box here. Okay, so that's some of the X-wings. Now, I think there's more of them. I gotta remember where they are, though. Let's look at this column. 3, 4, 5, and 9 is what's left in the column. This can't be 3 or 9. This can't be 4 or 9. That can't be 3. Okay, 5s. This is kind of like what we did over here with the 7 and the 8. The 5, we've got 5s here, so we can't have a 5 in any of these or up there. Oh, it's not quite the same. I thought it was the same because I wasn't seeing this 5. Actually, it's just a normal, plain old Sudoku puts a 5 there. So these are not 5s. So there's a 5 down here. And let's see, what's in these? These are 1, 2, and 6. What can we put over here? Oh, these are 2 and 3 just from the column because it's the only things left. And now we have a 1, 2, 3, 6 quadruple, which is going to give us 4, 9 pairs. And now we also have a 4, 9 pair here, so this can't be 4. It's very nice. And now, what can we do? Let's see. I'm going to fill in this column. 1, 3, 4, and 9. This can't be 1, 3. this can't be 4, 9 because of the 4, 9, but also because of 4, 9 here. These can't be 3, 9. So I think maybe we can do something with 4s potentially. Is that going to be helpful? I think there's something we can do. I'm trying to remember how it works. There's something with 4 and 9 in the middle here. All right, so these are 1, 3, 4, 6, 9. This can't be 4 or 9. This can't be 3 or 9. Ooh, it can't be a 0 for sure. This can't be a 3. I think. Let's see, what can we do? There's something we can do. Four's there, and it's been a while since I solved this puzzle, so I'm trying to remember what it is I need to do. 2, 4, 6, 9. This is not 9. This is not 2 or 6. This is not 1 or 4 or 6. All right, I'm probably just missing some obvious scanning thing. There has to be a 6 here. Okay. 1, 2, 3, 6. The 6 has to be in there, so this cannot be a 6. And now that forces a 6 into one of these two. Oh, we already removed the 6 from there, didn't we? Okay. But we know there's a 6 in there. So what can we put in here? 1, 4, 5, 6. This can't be a 4. The 5 here puts 5 there, so these are not 5s. 5 up there. Oh, well, these can't be 6s. Duh. Okay. Okay, and that gives us a 1, 4, 5 triple. So this is not 1 or 4. This is not 4. There we go. And now, right, and now we have our 4 X-Wing. Look at this. So in column 2 and column 8, those are the only options for 4s. And so what that tells us is if we put a 4 there, you have to put a 4 here. Right? And if you don't have a 4 there, you have to have a 4 here. So one of these two has to be a 4. We can remove 4s from all of those, and that gives us a 6 right there. This is not 6. This is not 6. And so then we can say, what can we say? Okay, 4 in this box. Can't be over here because of that 4. So one of these has to be a 4. So that's going to remove 4 from there. So it's a 1 or a 6. Okay, and now, oh, this can't be 9. Right, this is the thing now. In this row, where can you put a 4 and a 9? These are the only two options for 4 and 9. So this one has to be a 4 or a 9. And now where do you put a 6 in column 5? Right there. These are not 6. This is not 6. Now where does a 6 go in here? Or another way to think of it is this is a 2, 3, 5 triple. 6, 2, 1, 3. And that breaks the puzzle open. 9, 4, 1, 4, 9, That was the important step right there. 9. So it's just a combination of X-wings, which I know can be difficult to spot sometimes, but um, this is 9, 4. But it's doable, you know. Especially if you get stuck on a classic Sudoku, start looking for X-wings. You're not necessarily going to find X-wings, but it's a good thing to look for. The 1 and the 6 here gives us the 2. This is now a 1, which gives us 3. 6, 1, 6. That 3, 1, 3. All right, now we just got to finish off the middle part here. So this is 5, 7, and 8. This one's not 8. This one's not 7. These are 2, 7, and 8. This is not 2 or 8, so it's a 7. 8, 7, 5, 8, 2, 9, 4, 1, 4, 5, and 9. Looks good to me. Timer stopped. All right, so that was the classic Sudoku. That is for the entrance. Now, if we go back to the PDF, you may note that there's this house up here and this scream down here. So we're going to go back to our puzzle, and we're going to note, I'm going to actually write it down on a piece of paper here, but, you know, old school note taking, right? Actually, how about we do this? Let's add, I can add, so that you guys can see it. I can actually add a notes thing here. Let me see. Okay, notes. There we go. So I can say scream equals 8, and uh-oh, what'd I do? I did something. Okay. Okay, here we go. House equals 5. Okay? There we go. All right, so we've got some notes there. Now, what do we do to get onto the next puzzle, right? Because, great, we solved this one, but what do we need to do with it? So, let's go back to our thing here. I'm going to zoom in a little bit. Now, clearly, these symbols at the top are probably going to be important, right? Like, it's a puzzle hunt. That's the kind of thing you'd be looking for. But what are they? Now, if you're familiar with the ciphers, you may recognize that this kind of looks like a pigpen cipher, and that's essentially what it is. But what we're doing is these are the boxes of the grid. So this one here with these 2 lines is the bottom left corner, right? This one here, with the kind of U shape, is this top middle box. And these other lines and dots, if you look closely, what you'll notice is those are actually the shape of the givens. So in this bottom left corner, there's this diagonal line, and that's the givens in this bottom corner. In this top middle, there's kind of this upside down Y, and that's the shape of the givens in that box. And then the dot is telling us which digit we use. So this first one, bottom left corner, upper right, so it's that digit right there, which if we go back to our puzzle is a 5. Okay, so we're going to have 5. I'm going to write these down. 5. Now, the next one is the top middle box. It's box 2, and it's going to be the bottom middle cell, which is going to be a 6. So we have 5, 6. Now we're going to do the bottom right box, the central digit, which is a 9. Okay, and then this next one is the middle box, okay, and it's the bottom right digit in that box, which is going to be a 3. Okay, back to the picture. Now we have the box 6, and it's the central digit, which is a 6. And finally, box 8 with the bottom left digit, which is a 1. So our password that we're going to get from this, is 569361. So let's go back to our files. Now, we don't know which which file we need to open. But if you just kind of think about it, okay, we're breaking into a museum. We got through the entrance door, right? We got the code to the entrance door. Where would we be going? Probably into the lobby, right? You go through the museum entrance into the lobby. So let's try lobby. And 569361, submit. There we go. So we're in the lobby. Okay, perfect. Let's move I'm going to move my notes over to this side. Okay. Well, let's stick them right there. There we go. That way they're not hidden. So we get into the lobby. Now there's a whole bunch of stuff going on here in the lobby. You'll notice there's not really a puzzle in the lobby. We do have some symbols here. Those don't really look familiar. There's some signs, access restricted. You can kind of see something inside there. Now, special collection, that was in the letter. That was where we needed to get into to get the final thing. So we could probably assume, since it's a puzzle hunt, we're not going to be able to get into there yet, right? There's these signs, sandwich and thermo. Those are Sudoku types, so that makes sense. It's the Sudoku Museum. So we can just kind of try and look around, and there's these clues. These are pretty clearly clues because they don't make any sense otherwise. The HG, the PB's mate, like, why would those be on a sign? That doesn't really make any sense, right? So it's clearly going to be a clue to something. So HG should make you think, hopefully, of the element Mercury, which has a weird abbreviation because it's HG for Mercury. It's not like ME or something, one of those. Because it's probably a Latin word. I don't know that for sure, but I'm guessing it's probably Latin. But at any rate, also the fact that it's a thermometer puzzle, Mercury is in a thermometer, hopefully helps. The idea was when you get into the lobby here, these first couple ones hopefully aren't terribly difficult. I know some people struggled with PB's mate, and I'll get to that in a second. But HG, hopefully with Thermo Mercury, hopefully wasn't too hard to figure out. Now PB's mate, since it was a sandwich puzzle, I had to do a PB peanut butter and jelly clue. I felt like I had to. Plus, the other reason I wanted to do a peanut butter and jelly clue is I used HG for Mercury. I was kind of hoping the PB would then make people think lead, because you're thinking, oh, I did HG for Mercury for elements, PB is lead, and kind of throw you off the scent. Some people struggled with this partly because they're from an area where maybe peanut butter and jelly isn't a thing that you eat. It's not a type of sandwich that you would eat. And so that makes it a little bit harder. Apologize. It is a little bit cultural dependent on that clue, but as you will learn as you move from room to room, it makes a circle. And so every room can be entered from either direction. So if you absolutely could never have figured this clue out, you could go the other direction to the thermo and keep going around, and you would get a different clue that would lead you into the sandwich puzzle. So the idea was you can get stuck on one clue and you can still get into everything. That was kind of the theory behind some of these clues and making it a circle. So that way, hopefully you weren't entirely stuck. I know some people were, but at least you had two options. So anyways, PB's mate, peanut butter and jelly, PB and J. So PB's mate, the mate to PB, is going to be just J. So I'm going to go to this. Let's see. Should we do the sandwich puzzle next? I'm going to do the sandwich puzzle. So we're going to go back to our Dropbox here. We're going to go to the sandwich puzzle. And the answer is just J. Just a capital J. That's it. Not a very secure password, but that's okay. Now we get into our sandwich Sudoku. So this is typical sandwich Sudoku. Numbers outside the grid give the sum of the digits between 1 and 9 in the row and column. We do have a symbol here, which you may recognize from the lobby on the door to the special collection. And you'll notice we have signs back to the lobby and a sign leading to the irregular. So, and again, we have our link down here for the how to get to the online version of the puzzle, which I am now going to go to. So let's go to the sandwich puzzle. Here we go, sandwich puzzle. So the thing to do with the sandwich puzzle is to start with the 1s and 9s. We've got a 1 and a 9 here. So I am going to gray out cells that cannot be 1s and 9s. Now this 9, so a 9 clue, now we can't use the 9, obviously. So we have to have at least 2. The most you can do is 3. We have to have at least 2, so we can't make either of these the 1. So the 1 could be there, and it could be here, because there'd be 2. It could be here, but it can't be all the way over there. Okay, now the 20 clue. The minimum to make 20, so 2, 3, 4, 5 is 14. Or I guess I should say the maximum to make 20. 2, 3, 4, 5, 6 is 20, right? 2, 3, 4, 5, 6 is 20. So the max you can use is 5 cells. The minimum would be 8, 7, 5, so 3 cells. So it's 3, 4, or 5. But the point is you can't put the 1 down here because you can't do 20 in 2 cells. So it can't be here, and it has to be at least 3. So the 1 is going to be in one of those 2, right? Okay. Now, where do we look next? So these bigger digits are helpful, but I'm going to actually do this one first, the 16. So 16, normally you could do 16 and 2, right? 9 and 7, but you can't use the 9 because it's part of the crust. So 8 and 7, 15 is the most you can do in 2 cells. So you need at least 3 to make 16. So we also can't do, we also can't put the 9 over here because you can't do 16 and 2. It needs to be at least 3. So you're going to have a 9 in one of those. Okay, let's look at the 19. Now 19, again, has to be at least 3 cells. So we can clear out those and that one. So there's a 9 in here. Okay, now the thing to look at is the bigger one. So 27. We can't use a 9. So 8, 7, 6 is the biggest you can do in 3, which is 21. 8, 7, 6, 5 is 26, which is the biggest you can do in 4 cells. So you need at least 5 cells to get to 27. And so if you put a 1 or a 9 right here, you're not going to have a chance of making 27. So we can rule that one out. Now 26 you can do in 5, right? 8, 7, 6, 5. Or you can do it in 4, sorry. 8, 7, 6, 5. But you can't do it in 3, so you need at least 4. And again, if you put a 1 or a 9 right here, you can only get 3 cells in either direction. So this one's ruled out. And now, since we know we can't put a 1 in either of these, the 1 is going to have to be in one of those, right? And there's going to have to be a 9 up here. But 11's pretty small. So what's the most cells we can use to make 11? So 2, 3, and 4 is 9. 2, 3, 4, 5 is 14. So we can't do 4 cells. The minimum we have to do at most 3 cells to make 11. Well, we've already got 3 cells in the middle here. So this has to be the 9, this has to be the 1. Okay, and now we can work off of those going the other direction. So the 9 here, 18 needs at least 3 cells, right? So we definitely can't do those. We definitely can't do these, because 18 needs at least 3 cells. Now the 1 here, 16, as well needs at least 3 cells. So we can mark those off. So we know there's a 1 somewhere out here and a 9 somewhere out here. And 27 and 26 are pretty big. And so what that tells us is they're not going to be the same. So one of them is going to be here and the other one's going to be there. They can't be in the same column because you can't do 27 or 26 in 3 cells. If that makes sense. So one of them is going to be here, and let's see, did we decide you need at least 5 for 27? So 27, 8, 7, 6, 5 is 26. So you need at least 5 cells. So one of these two has to be a 1 or a 9, because we can't put both of them over here in this row. So one of these two is a 1 or 9. You need at least 5 cells to make 27. So if it's here, you're going to have to be at the top. If it's here, you're going to have to be at the bottom. So what that tells us is these cannot be 1s and 9s. Now over here, you can do 26 and 4, right? 8, 7, 6, 5 is 26. So we don't quite have the same problem. But we know we can't be any of these, right? Because if it's here, 3, 4, it's going to be one of these top 2. And if it's here, it's going to be one of these bottom 2. So that means this is not a 9. Ooh, that's the wrong thing. Which means this is a 9. Perfect. Now the 13, working off of this 9, 13 needs at least 2 cells, right? So this can't be. This can't be. But can we do 3 cells? I think we probably can. 2, 3, and 4 is 9. So yeah, you can do 3. So we're either going to have a 1 down here or a 1 up there. But look in this box now. Where can we put a 1? The only option left is right there. Now, 19 needs at least 3. So we can do those. And over here, 21, 8, 7, 6 is 21. So you can do it in 3. But one of these is a 9. One of these is a 1. Okay. And because there's not a 0 clue on the column, we can't put the 1 and the 9 in the same spot here. They're going to have to be kind of in an X shape. So let's see, what do we do next? So we know this 26 here. So we decided that 26 needs at least 4 cells, right? So we could, you could do this one, couldn't you? 9, it would force a 1 over there. I was thinking we could rule out all 3 of these, but we can't quite do that because you could put a 9 with a 1 like that. We can rule these out and this one, because we've already got the 9 and the 1 in the column. Okay, so 20 needs at least 3, right? 8, 7, 6, yeah. So if we put it here, it would have to be, the 9 would have to be on the opposite side there. Trying to remember where to go from here. Okay, maybe the 14 or the 17 will give us something. Can you do 13 and 4? I don't think you can do 13 and 4, right? 13 has to be 2 or 3. 2, 3, 4, 5 is 14. Right, so this one cannot be the 1. So there's a 1 in one of those two. 13 here also can't be. Oh, but we can do. So we have to do. Okay, right. The 13 is the place to look. 13 needs at least 2 cells, right? So we can't do the 1 and the 9 over here. So what that tells us is one of the crusts is over here and one of the crusts is over here. But 13 can't be more than 3 cells, so it has to be those. That was what I needed to see. Should have seen that earlier. Okay. So a lot of times it's just, just like any of these puzzles, looking in the right place is important. I mean, it sounds kind of silly, but that's a big part of it, is just knowing the right place to look. Okay, and that gives us the 1 and the 9 there. So this is gray then. One of these has to be 9. But the problem, okay, so now the thing to look at is the 26 needs a crust here and a crust over here, right? This 26 needs a crust here and a crust down here. So we need a crust in one of these 3 and a crust in one of these 3, but we've already used one of our 2 potential crusts in this box. So the only way to satisfy both of those is for it to be right there. Okay, and now 26, the minimum, let's see, what's the most we can use? Well, 26, we know that 45 minus the 1 and the 9 that are the crusts, wherever those are, is 35. So outside of the sandwich, we need to have 9, which is going to take at least 2 cells. So we need to have at least 2 cells outside, so that's going to give us a 1. Same deal over here, we need at least 2 outside, that's going to give us a 1. Now 14, this can't be a 1 anymore because of the 1, so that gives us these. Because remember, they had to be in an X shape because neither one of these clues is a 0. So these get grayed out there. Perfect. Now, we finished this column. These two are the only two left for the row, and so we have to use both of those. This is now grayed out. This is the only one left in that row. This is now the only one left in the column. Oop, wrong one. There we go. That gets gray. This is the only one left. Okay, now we have all of our 1s and our 9s. Now, I'm gonna, before I solve the rest of it, I'm gonna pause for a second and look back at the PDF, because what I want to point out is, let's look at the irregular clue. Okay? Look at that clue, those lines. Okay, and now let's look back at the grid. Does that look familiar? These lines are the 1s and the 9s. The pattern of the 1s and the 9s in the grid. And so what that tells us is that A and B are going to be these two cells. Those are going to be our code for the irregular room. Okay, so I'm going to solve the rest of the puzzle now, but these are going to be the two, the A and the B, that we need for the code to the irregular room. Okay, so let's see. Where's a good place to start? We want something that's right here, the 9. The 9 clue in 3. Can't use a 1. It has to be 2, 3, and 4. Okay? 14 in 3 could be a few things, I guess. What about 11 in 3? Maybe that one will be good. 2, 3, 4 is 9. So we could do... Can we do it with, can we not use a 2 is the question. 3, 4, and 5 is 12. So we have to have a 2. So we know this isn't a 2. We have to have a 2. And then the other 2 add to 3, 4, and 5 is, yeah, so the other 2 add to 9. So 2, 3, 6, or 2, 4, 5. Okay? So there's a 3, 6, or a 4, 5 in here. There's a 3 or a 4 in here. So that's our 3 and our 4. So we can't use 2, 3, and 4 anywhere else. These are going to be 7, 8, 5, 6. 5, 6, 7, 8. There we go. Because we're either going to use a 5 or a 6 in here, and the other one's going to be out here. Okay, so 19 here. We've got, this one's pretty small. So the most we can do here, 8 and 4, is 12. This would have to be 7. Can we do a 3? If we have 3, we'd need 16, which would have to be 7 and 9. So no, this has to be a 4. With a 7, 8. So this is not 4. And these are not 4, 5 now because of the 4. So that gives us 2, 3, 6. These are not 6. This is not 4. Perfect. Now we have 5, 7, and 8 here. We need to get to 20. So really, whatever we have here, it's going to put the same up there, essentially, is what you're going to have. You can't have a 6 in here. 5, 7, 8 is going to be required for 20. And so, since we know there's a 5 here because of the 5, 7, 8, this is not a 5. And these two are going to be the same digit. 1, 2, 3, 4. So this is 5, 6, 7, or 8. Let's see. Oh, let's look at the 16 now. So 8 and 6, this could be... Yeah, that could be quite a few things, actually. Okay, let's not look at that one. The 26s, are those going to be helpful? Maybe the 27 will be more helpful. So outside the 27, we need 8, which has to be 2, 6, or 3, 5, because we can't use a 1, right? 2, 6, or 3, 5. And then these, outside the 26 is going to be 9, so we can put kind of the counterpart there, right? So 2, 7, 3, 6, 5, 4, 6, 3. So if this is 3, 5, then this would have to be 4 or 6. Yeah, okay. Good. Let's see, where else should we look? 18 maybe. So this, we have 8 or 7. So we need either 9 or 10 in here. I don't know how helpful that is. Maybe the 13 is a better place to look. Oh, the 14. 14? We've got a 2 or a 3 here. So this is going to be 11 or 12. So if we put a 3 in, then we need 11. It can't be 8, 3. It can't be 9, 2. It would have to be 4, 7. Or, 5, 6. 4, 7 or 5, 6, I guess. If it's 2, it needs to be 12. It can't be 9, 3. It would have to be 8, 4, 5, 7. That wasn't as helpful as I was hoping. Okay. 16, 8. Okay, the 18, the 16. What about the 20? Ah, the 20. Yes, yes, of course. So we need 15 on the outside, right? And we can't use a 9, so it has to be 7 and 8. There we go. Now this is, remember, we need 9 on the outside of the 26 cage, right? So these two have to add to 9. Well, 8 would require a 1, which we can't do. So this has to be 7 and 2, which gives us an 8 there. Now these are 3, 4, 5, and 6. So the 19 now, the maximum we can get here is 11, which would force an 8 there. So we have to use the maximums, which gives us 8, 3, 4, which is 15. We need to have 22 on the outside, so this has to be a 7. 2, 5, and 6 in the middle, which should hopefully add to 13, and it does. Good. The 2, 3 pair here means that's not a 2. 5 and 6. What do we have left here? These are 2, 3, 4, and 7. These can't be 7s, so that gives us a 7 there. This is not 7. This is now 5, 6. Ooh, wow, that was all the wrong digits. 5, 6, 8 for the row. So where can we put a... Oh, and the 8. Look at the 8 there. So we have a 5, 6 pair. Gives us a 2 and an 8. These have to be 3 and 4 now. These are 5, 6, 8. We have a 2, 3, 4 triple there. So we can do that. Okay, so that's the 26 clue. We've done the 13 clue. We've done the 19. We've done the 20. We've done the 11. We've done the 19. So let's look the other direction. What about the 16? Can we do anything with the 16 here now? So we know we need to have either 8 or 9, right? That's going to be quite a few options still. Okay. Maybe that's not the place to look. The 17, 14. Where do we want to look now? Oh, the 18 here maybe? Is that helpful? So we said we had to have 9 or 10. We could have 6, 4. We could have 5, 4, or 6, 3. Yeah, so that's not going to be helpful, is it? Maybe the 21 clue. 21. Oh, 21 has to be 8, 7, 6, doesn't it? Should have done that one right from the start. 5 and 6. This is 3 or 4. And so now we've got a 6 here, so the other two have to equal 12. The only way to make 12 with these is 8 and 4. This is going to give us the 3. That makes this a 4. These are not 8, and so this one is an 8. This is 7. This is not 7 or 8, so it's a 6. 2, 3, 6, 5, 7. Okay. Good. Looking good there. These are 2, 3, 5, and 7, and this one can't be 7. The 7 here means that's not 7, which means this can't be a 2, because remember, these have to sum to 9. And if this can't be a 2, that can't be a 6, because these have to sum to 8. Where do we look now? We've done the 21, we've done the 18, we've done the 20. We're close on the 27. We haven't done the 17 yet. 21. Oh, we've got the 8 now. So the 21, that tells us we need 13 in between. So these have to be 6. Oh, 21 has to be 8, 6, and 7. We had that up here too. We should have seen that one earlier. It's bad solving. All right. That gives us the 5, 6. So these have to be 3, 4, 5 somehow. Hold on a second. My dog's doing something outside. All right, so we should be able to finish off this 16 clue now because 8 and 5 is 13. So that gives us 3 and 2, and that gives us the 3 over here. These are not 3s. That 4, 5 pair comes back over here. Now, let's see. What can we do? Ah, the 4 there. 5, 4. So now we have no 5 down here. This cannot be 3, 5. This has to be 2 and 6, because remember we have to have 8 on the outside. It's not 2 or 5. 3, 7. This is a 7 and a 3. 3. These are 2 and 6. There's a 7 in one of these because of this 2, 5, 7 triple. So that gives us 8 and 7 there. The 6 down here, these have to add to 9, so that's a 3. This is not a 3. These are 4, 5, 7, and 8, and these cannot be 7, and those two cannot be 8. Now this has to be 16, and we've got 7, so we need 9 more, so that can't be 8. It's got to be a 4, 5 pair, which means this is a 7 and this is an 8. It's not 4, that's a 6. This is also not a 5. 8, 5. The 2 there. So these are 3, 4, and 6. This can't be 3 or 6. 4, 3, 6, 2, 4. So we've got one of our digits. This is not a 5. We've got one of our 2 digits for the password. This is a 3, just to finish off the row. These are 2, 5, and 8. This one can't be 5 or 8. It's a 2. This one also can't be 8. It's a 5, 8, 2, 5. We've got our other digit for our password. This is a 7. That 5 gives us 4 and 5. This is 2 or 6. This is also 2 or 6. Which we will get from the sandwich, the 17 here. So we have 7 and 4 is 11. We need 6, 2, 6. These are 3, 4, and 5. And this one has to be the 3 and the 5 and the 4. Oh, and then we got to finish the 5 and the 6 over here. It looks good to me. So there you go. That is the solution to the sandwich puzzle. Now, if you remember, over here we had the pattern of the 1s and 9s, and then the A and the B. So the A is top left, B is bottom right. So going back here, that means our password is going to be 52 for the irregular puzzle. So let's go to the irregular puzzle now. Let's see, I'm going to zoom back out of this. Oh, that's not how I want to do it. I want to zoom out. Actually, I think if I just go back, it'll be fine. There we go. Yep. So now we're going to go to the irregular. Password was 52. Submit. Here we go. Here's the irregular puzzle. So, looks very familiar to the last room. Again, we have clues. So this is leading back to the sandwich. So the clue here, let's zoom in on it a little bit, make it nice and big. If you weren't able to figure out PB's mate, you could go through the Thermo room, go all the way around the circle, and you'd end up into the irregular. You'd solve this, and then the clue to get back into the sandwich would then be I blank K. Now, just simple alphabet stuff, I, J, K. So it's just a capital J. Same answer, of course, because the password is the same no matter which direction you come to the room. But now the other one, I'm going to zoom in a little bit again here. You'll notice we've got kind of these weird shaped lines here. Now, if you compare that to the grid, you will see actually that that is the shape of the regions. And so what that's telling us is the password for the clone is going to be the digits along that kind of diagonal line that goes right through here. Those 5 digits are going to be our password to go to the clone room. So this is just normal irregular Sudoku. Oh, on the last one, we should have written down. Let's go back. I forgot to do. The password was just a J. We needed to look at this shape in the middle, didn't we? So let's go back to our sandwich grid. I still got it open. That's that. So that is going to be the 6. So that is, it's a little hard to see. It's kind of small on here. But what that is that is sort of a painting. I think it's by Marguerite. I'm not entirely sure, but it's like a guy's face with an apple in the place of his face. But anyways, so that I'm going to add that to our notes that we've got over here. Let's see, notes. We're just going to say apple equals, was it a 6? I think it was a 6. Let's double check. Yeah, it was a 6. So apple equals 6. Okay, perfect. Now, let's move on to the irregular, which we said the password was 52. Submit. There we go. Okay, so the regular puzzle, and again, you've got this link down here to the online version. So we will jump over to that. There's the irregular puzzle. All right. So, irregular can be a little tricky. So we'll see if I remember how to solve this one too. So we know. What do we know? Okay, so there's not a 1 in here because of this one, right? So there has to be a 1 over here. There's not a 5 in here, so you have to have a 5 up there. And the 5, we can't have a 5 in there. We can't have a 5 right there. So the 5 in this region then has to be in one of these two, which then means there's a 5 in one of these. Okay, let's see. What else can we figure out? So 4 can't be in any of those. So 4 has to be in one of those. So this is kind of how irregular works. You just sort of have to look at the weird way that things interact. Like the 2 rules out all those. This 2 rules out that one. So you're going to get a 2 in one of those. Just kind of weird stuff like that. Now, another thing you can look at is this region here. Where's a 2 going to go? These 2's rule out those. So there has to be a 2 in column 1 over here, right? Oh, well, actually, that didn't. I was going to say that rules out 2's from here, but we already have a 2 right there anyways. So that didn't actually help that much. I think I'm going to delete those for now. 3's can't be in any of those. So these are 3's. So now 3 in this region down here, it's ruled out of those because of this. And these 3's ruled out of there. So there has to be a 3 in one of those two. There has to be a 3 in one of these. Ones. So these are ones. What can we do next? Let's see. We have to have an 8 in one of those. There has to be an 8 at the top here because you can't put an 8 in any of those. Trying to remember where the place to look in here is. It's a lot of scanning is what these puzzles are, which can be tricky sometimes. So this 8 here is in this region, right? So where can we put an 8 in this column? It has to be up here, but we can't put an 8 there. So this has to be the 8. There we go. That gives us something. This 5 rules 5's out of those, so there has to be a 5 in one of those two. Now we don't get quite the same thing that we did with the 8 up here. But the 6 here can't be in any of those, has to be up here. That's not a 6, so this is a 6. Now, can we do the same thing with 7? 7 has to be in one of these two. Yep. So 5 in this row can't be here, can't be there, can't be in these because we know there has to be a 5 in one of those two. So there's one of these two as well. And in this row, it's got to be in one of those. Let's see, can we do the same thing with the other ones? Let's see, the 5s, the 7s. Let's try the 7s. So 7s can't be in any of those. Yeah, but we don't have any restrictions on 7s up here, so that's less helpful. All right, let's keep working with 8s maybe. Can 8s do anything else for us? We've got columns 1, 2, and 3. We know there's an 8 in there. Can't have an 8 in any of those. There's got to be an 8 in one of those 3, but... so we can't have an 8 in here. So in this region, you can't have 8s in any of those. So 8s have to be in those two. Excuse me. 3 in this region. That 3 there rules it out of all these. So it has to be one of these 3. Can't be up there because of that 3. And it can't be down here. So this is a 3. And now, so we can't have, we can't have a 3. I think this was wrong to say the 3 is down here. I did that wrong. That was wrong. Wasn't it? Ah, no. I see what I did wrong. Okay. That was kind of right. So what I said was there's a 3 here, so we can't put a 3 anywhere there. So there has to be a 3 in one of these, right? But actually, you also can't put a 3 in any of these because of this 3, so there has to be a 3 in one of these 4. So the only way you can have a 3 in here and in here is if it's in the corner there. That's where I went wrong. Now we have a 3 in there. We have a 3 in here. 3's there. Where else can we put a 3? I think those are the only options. 2, 3, 4, 5, 6. Yeah, we've got 6 3s, so we need to put 3s in those. Okay. Let's keep looking for things that we can get. Let's see. Similar types of things. Now the 5, we said there had to be a 5 in one of these. There also has to be a 5 in one of these two. Just in this region, because you can't put a 5 here. So there's a 5 in one of those two in the region. So 5 in here in this region. It's not super helpful, is it? 2 can't be in any of those, so you have to have a 2 over here. 2 also can't be in here, so you've got to have a 2 up there. Which then means you can't have a 2 in here, but you could have it in the corner. So that doesn't really tell you too much about over here. Interestingly, we have to have a 2 here. We have to have a 2 here. So, unless we have a 2 in a corner, if we don't have a 2 in a corner, that means that there has to be a 2 in that corner. So there's a 2 in one of the 3 corners. I think, actually, that's true of all of these, isn't it? I think you have to have 1, 2, 3, and 4 in the corners. Because the thing is, the 1 here means you can't have a 1 in any of those, right? And so in this in the column 1, you have to have a 1 down here. And, well, actually, no, we can do it this. So this tells us we can't have a 1 there. We have to have a 1 over here. This one tells us we can't have a 1 in this part of column 9. We have to have a 1 in there. And again, just like the 3, the 1 has to be in the corner. And now the 2 and the 4, I think, are going to be the same way. The 4, can't put a 4 anywhere in here, right? But we have a 4 there, so we also can't put a 4 anywhere in here. So we need to have a 4 somewhere in this row, somewhere in this column, but we also need to have, or somewhere in row 1 and row 9 in those cells, but we also need to have a 4 in column 1. And that's 2 regions that need 3 4s. So the only way to do that is to put a 4 in the corner, right? Because we need a 4 in row 1, a 4 in row 9, a 4 in column 1. But we only have 2 regions here, so we only have 2 4s. So one of them is going to have to be in a corner, and it has to be this corner because we can't put a 4 in this corner. And that means there's a 4 in one of these. And now I think the other corner is going to have to be a 2 because, again, the 2 can't be in any of these. And so we have to have a 2 in here. So you can't put a 2 there, which means you have to have a 2 in here. So you can't put a 2 there, can't put a 2 there. So the only place to put a 2 in column 9 and row 9 is in the same region. You only have 1 2 to use, so it has to be in the corner there. And so these 4 here that are kind of stuck in have to end up being the corner cells just because of how the regions work out. All right, so what do we do next? So we can't put a 3 in there. We have a 3 there. Okay. 1, 2, 3, and 4 are done for those outer regions. I think because of the, well, we've got them pencil marked at least, if not in place. This one can't be a 2. Oh, this one can't be a 5. There's that 5 there. So there's a 5 in one of these two. So there's a 5 in one of these. There's not a 5 there. There's a 5 up there. There's not a 5 here. There is a 5 down there. Okay, yep, that works. That all works. 5, this row. There's a 5 already in there. What about this row? Where can we put a 5? We can't put it in any of those. We can't put it up here. Could put it in there though, couldn't we? So one of those two is a 5 in this column. I want to just highlight our options for 5s here for a second. See if any patterns show up. So these can be 5s. These can also be 5s. Can't put a 5 in those. Is that all of our options for 5s? No, it's not. These can be, and that one, right? Those are our options for 5s, I think. And so what that's telling me is, let's look down here. These are the only 2 places you can put a 5 in this row. These two in here are not options for 5s because of the 5 being limited to these 2 in column 7. It rules out 5s from the rest of these cells in that region. So this row has 2 options. This row has 2 options. We need to put 2 5s in there. Yeah, but we don't have to use that one necessarily. Okay. Yeah. So if we go there, yeah, okay. Never mind. I wanted to say we had to have a 5 there, but that's not true. That's false logic. So ignore that. Okay. Let's go back to what we were doing. So we can't have a 6 here. 6 down here, which means you can't have a 6 here, so there's a 6 in these. And now I think those are a 4, 6, 8 triple. Right? You can't have 4 or 8 over here, so they have to be down here, and you have to have a 6 in here, so you can't have a 6 there, so you have to have a 6 here. So these are a 4, 6, 8 triple. So we can just make those This is a 1-7 triple, or a 1-7 pair, sorry. Okay, which means there's no 7 here. There has to be a 7 over here, and it can't be right there. So this is the 7. These are 5, 6, 8, and 9. This can't be 6, 5, 6, or 8, so this has to be a 9. These are 5, 6, and 8. This one can't be 8. 5, 6, 8 is going to give us 7 and 9 pair up here, which makes this a 2, 5, 8 triple. This can't be 5. 2, 5, 8 triple. That 2, 5, 8 triple gives us a 7 and 9 pair over here as well, which is going to make these a 2, 5, 6 triple. This can't be 5 or 6, so that's the 2. So we have a 5, 6 pair right there. 2, 5, 8, 5, 6. Okay. Good. So these are 1, 2, 4, 8. I believe this can't be 2 or 4. These can be any of those, I think. Yeah. Okay. It's good progress. Good progress. This can't be a 6. That gives us the 4 there. So we have a 6, 8 pair now here. What are these? These are 1, 5, 7, and 9. This one can't be 1. This one can't be... It can be everything, I think. No, it can't be a 5 because we have to have a 5 in one of these two in this region. Can we do 6, 1? 1 has to be in one of these two in this region. So this cannot be a 1. Okay. Back over here. 1, 5, 7, 9. So this can't be 5. This can't be 1. This can't be. Is there anything this can't be? I think this can be any of those still. Yeah. I think so. But we have to have a 7 in one of these two because of this row. So this can't be a 7. Let's see. One of these 5. These 8. Okay. So what else can we do? 1, 5, 7, 9. Where can we put a 4? 4 has to be in one of these two, doesn't it? Is there any reason we can't put a 4? One of these is a 4. Actually, let's finish 3, 4, 7. Let's fill these in. These can't be 3, 4, or 7. This is a 9. There we go. That was a better place to look. 7, 9. Now these two can't be 7s. Those are a 3, 4 pair. 9. That 9 is going to give us 5, 6, 5. This can't be 5 now. The 9 there means this is not 9. So that's 1, 7. This can't be 5. So we have 1. This can't be 5. And so where can you put a 5 in this row? It has to be over here. And now where can you put a 5 in this row? It has to be here. Very nice. 1, 7, 9. These are not 3, 5. Okay. So can we do anything with... So there's a 7 in here. There's also a 7 in here, which means there's a 7 with those. Let's see. Let's fill these in. There's only 3 left here. 4, 7, and 8. This one can't be an 8. This one can't be a 4. We got 4s in there. Oh, where does 4 go in this region? Because the 4 there. This is the 4. That's a 3. Okay, so these are not 3s. Got 3s here. We've got 3s here. And then, yeah, that's all the 3s, I guess, isn't it? Just those 2. Okay. 4 can't be there. 1, 2, 4, 8. What are our 4 options? 1, 2, we got there, there. These 2. Is that it? 4. Oh, this one can't be a 4. Look, the 4 up there. So this can't be a 4. So where can 4 go in this row now? Can it be here? Well, actually, let's look in this region. 4 can't be in any of these. It can't be there. It can't be there. This is a 4. And so now you can't put a 4 in any of those. So you've got these 2. And these 2, I think that's it for 4s, right? Yeah, so this can't be a 4. These, yeah, we've got 2 options still for the 4s there, though. Okay. 3. We're narrowing in on the solution here. Slowly but surely. That's kind of how irregular works. You just sort of whittle your way down until eventually you can fill everything in. Let's see. These are 1, 2, 6, 7, 8, I believe. This can't be 8. This can't be 1 or 2. This can't be 1 or 7. This can't be 7. This can't be 7. So 3 over here. There's also a 9 in one of these 3. Oh, look, the 7 there. That was one of the givens, too. Had that a long time ago. All right, which means there's a 1 here, because you can't put a 1 anywhere else in that region, which means these are not 1s. So now you have a 7-9 pair. Should have had that a long time ago. All right. 7, 9. So these 2 are going to be the same for whatever that's worth. You don't have a 1 in here. So these are 2, 3, 6, 9. This one can't be 3. This can't be 2. 3 or 6. That's a 2 or a 9. And whichever one is here has to be. Oh, okay, yeah. Wait, if this is a 9, yeah, where do you put a 9 in here? The only place to put a 9, because the 9 here has to be in this column, so this has to be a 2. Now the only place for a 2 in this row is right there. We get a 3, 6, 9 triple across here. But we've got a 6, 8 pair there, so this can't be a 6. 3. So the 6, 8 pair plus the 1, 2, 4 means these are 3, 7, 9, and 5, I think. This can't be 9. This one can't be 3 or 5. Oh, so 7, 9 pair. So this can't be a 7. This can't be a 9. This is a 3, 5. This has to be a 3 now. This can't be a 3. We have a 6, 8 pair here. That's a 9. That's a 1. 6. 6. Oh, the 9 there. Again, a given looking right at a pair that I put in there a long time ago. 9, 7, 9. It's the way these puzzles go sometimes. Irregulars are really hard to scan, I feel like. Because you don't have your normal boxes that you're looking at. These are 7 and 2. That leaves 9 here. This is not a 2. So we have 5, 6, 8, but we can't do a 5. So a 6, 8 pair gives us a 5 up there. These are 5, 6, 7, and 8, but this one can't be 5, so the 5 has to be there. 6, 7, 8. The 6, 8 pair here gives us a 7, 8, 6, 8, 6. This is not 8. These are 1, 2, and 4, but this one can't be 2. This one can't be 2, so that's a 2. 8, 2, 6, 8, 6, 8. This is a 1, 4, 1. This is not 4 or 8. It's a 7. This is a 4. This is now a 5. Oh, sorry, not a 5. Scanning is hard. 9. This is an 8. Looks good to me. All right, so there is the solution to the irregular puzzle. Now let's get our, there's a digit that we needed, right? Let's go back to here. So there's an artist brush there, it looks like, and it's in row 7, column 5. So that is going to be right there. It's a 1. So the brush is a 1. Let's add that to our notes here. Brush equals 1. Okay. We also need to get our pattern for our code. Now, if you remember, it was these right here from the line on the thing here. So we don't necessarily know the order, but it's 2 options, right? So it's either 3, 4, 5, 4, 5 or 5, 4, 5, 4, 3. And that leads to the clone puzzle. So let's go ahead and go back and we'll click on the clone and we'll try 5, 4, 5, 4, 3 and it says incorrect. So 3, 4, 5, 4, 5 and that one is correct. So now we are in the clone puzzle. Now this one is a double Sudoku. I gotta stretch a little bit. It's important to take breaks to stretch when you're solving Sudoku. Let's see. I got a bright light on my face there. Maybe that'll help a little bit. As the sun moves, I've got windows on both sides of me here. And as the sun moves, the lighting changes, so. All right, so now this is the clone puzzle. So it's just standard Sudoku rules, plus we have these clones that have to be the same. So the gray, the blue, the yellow, and the red in the 2 puzzles have to be the exact same digits. So I'm going to probably jump around a little bit between the 2 puzzles. We've got our irregular clue. So we already were at the irregular, and that's going to be our tint tally. So what that means is the sum of the digits in the colored regions. The tint area tally is the total. Now, we could use that knowledge, of course, because we know the password to the irregular puzzle was 52. So at some point, we might be able to use that to help us. Now, you don't have to use that. That is not necessary for solving this puzzle. But you could use that to help you a little bit. Now, going to the killer, let's look at that one here, the clue. So if you kind of look at that and look at the grid a little bit, you'll notice that you have these lines that kind of match where the colored regions are, and then there's this little bit sticking off in the corners. And our 2 puzzles have, you know, this whatever modern art looking thing here. One is sticking out one corner and one is sticking out the other corner. And so that's showing us kind of the pattern in the grid. And so what we really need for our password to go to the killer is these dots. The center cell of the 2 puzzles is going to be our password to the killer. Okay, so as usual, we've got the links down here. So I've got those opened up. Let's see, let's go back to our thing. So I've got both of those here. Got the 2 of them. So I'm going to kind of jump back and forth between them a little bit because we're going to use these. So I'm going to start with the gray corner. Why not? So this sees 1, 3, 8, and 9. The other one sees 2, 4, 7, and 8. So that is, oh, and it also sees a 5 here. So this sees 1, 3, 5, 8, and 9. The other one sees 2, 4, 7, and 8, and a 1. But the point is, it sees 1, 2, 3, 4, 5, 7, 8, 9. That has to be a 6. So we can fill that in on both of them. Okay, now let's go to this corner. This sees 2, 4, 8, 9. The other one sees... let's make it a little bit easier. Let's do, so 2, 4, 8, 9. So 3, it could be 3, 5. It can't be a 6 anymore. So 3, 5, and 7. And 1. 1, 3, 5, and 7. I think are the options. Yes. 1, 3, 5, and 7. The other one sees 7 and 5. So it can really only be a 1 or a 3. Okay? Let's jump down here. This one sees 2, 4, 5, and 7. So we can have 1, 3, 6, 8, 9, I believe. But it sees 3, 6, 8, and 9. So it has to be a 1, which then means this one up here has to be a 3. Okay, let's jump over to this corner. This sees 1, 2, 6, 8, and 9, so it can be 3, 4, 5, or 7. Oop, wrong puzzle. 3, 4, 5, or 7. And this one sees 3 and 4 and 7. So it actually has to be a 5. So we can get those 4 corners right away. Okay, now we can start doing the other colored cells here. So this one now sees 2, 3, and 4, 6, and 7. So 1, 5, 8, and 9, I think, are the options. This one sees 8 and 9, so it's got to be a 1 or a 5, right? Let's go to the right one. So this is 1 or 5. This one, 2, 5, 6, 8, and 9. 1, 3, 4, 7. Oh, it sees a 4 as well. 1, 3, and 7. This one sees a 1 and a 3, so it has to be a 7. So go back and fill in the 7 there. So this is a 7. All right, keep working our way around here. This is 1, 3, 4, or oh, can't be a 9. It's 1, 3, or 4 because it sees 2, 5, 6, 7, 8, and 9. So it's 1, 3, or 4. This one sees a 1 and a 3, so it has to be a 4. It sees the 1 and the 3, so it's a 4. So you can actually get these colored digits pretty well all by themselves. 1, 5, 8, and 9, and 4. So 2, 3, 6, 7. 2, 3, 6, 7. This sees a 3 and a 7, so it has to be a 2 or a 6. So a 3 or a 7. So I wanted you to be able to kind of pretty much figure out the colored cells to start with, because it can be a little complicated working with 2 grids. Now, if I was solving this just by myself, I would actually be opening them both up on opposite sides of the screen. But just to make it fit on the screen here for the video, I'm jumping back and forth. But I would actually probably open them both up and do it that way if I was just solving it by myself. Okay, this one can't be, let's see, 2, 3, 4, 5, 6, 7. So it can't be 5, 6, 8, or 9, or 1. So it's 2, 3, 4, or 7. And this sees a 7 and a 2. So it has to be a 2 or a 3. Or it sees a 7 and a 4. Sorry. So it has to be a 2 or a 3. So this can't be 4 or 7. This one sees 2, 4, 5, 6, 7, 8, 9, I think. It sees 1, 2, 3, 5, and 6. Oh, it sees a 2. So it's 4. Oh, it sees a 4. It's 7, 8, or 9. 7, 8, or 9. And this one sees a 9. So it's 7 or 8. Okay, working our way up here. 2 can't be a 4. It sees 1, 3, 4, 5. It can't be a 6. Can't be a 7. 8 or a 9. So it's 2, 8, or 9. And this one sees a 9 and a 2. So it has to be an 8, which is going to make this one a 7. So we can go fill those in over here. 8 and 7. And our final colored cell here, 1, it sees 2, 3, 4. It can be a 5. It sees 6 and 7, 8, 9. 1, 5, 8, 9. And this one sees 1, 8, and 9. So it has to be a 5, which is going to give us the 1 there. 5, 1. Very nice. Now, these are the only 2 that we haven't disambiguated here. The 2, 6, and the 2, 3. So, that's okay. We'll get those figured out. So now we can just do normal Sudoku on the grids individually until we figure out those 2, and then we'll go back and fill those in on the other side. But we can just do normal Sudoku now. So I'm going to fill in, are these row 3 and column 3 and row 7 and column 7 have a lot of digits already. So I'm going to fill in our candidates there. 2, 4, and 9. Well, this one can't be a 4, and this one can't be a 9, and this one can't be a 2. Funny how that works, huh? This one, 1, 3, and 9. This can't be a 1. This can't be a 9. Now, this one doesn't have the same restriction, but that's okay. 2, 8, and 9. This one can't be 8. This one can't be 2 or 8, so it's a 9, which gives us a 2 and an 8. This one is going to have some more options because we don't have the 2, 3, 6 thing figured out, but we're going to have 2, 3, 4, 6, 7 as options here. This can't be 2 or 4. This can't be 3 or 6. This one can't be 2. think that's all we can do there. Okay, now I'm going to go back to the other puzzle and do the same thing, and I want to see if we can figure out the 2 and the 2, 3, 6 there. Okay, so these are 2, 8, and 9. This one's not a 9. Ah, this one's not 2 or 9, so it's an 8, 2, 9. There we go. Now let's do this one next. 2, 4, and 7. This can't be 2 or 4, so it's a 7. This one can't be 4, so it's a 2. That gives us a 4 there. This way, 1, 2, 3. These are 5, 6, and 9. This one can't be 9. This one can't be 5 or 9, so it's a 6, 5. Oh, mistype. 5, 9. There we go. Excuse me. Now let's fill in these across here. So these are 2, 3, 6, 8, 9, I believe. This can't be 8 or 9. This can't be 2 or 3. And this one can't be 2 or 6. So we have a 2, 3, 6 triple. So this can't be 6, that can't be 3. That gives us 8 and 9 there. It's very nice. We can't put 8s in any of those. There's 8s here. We can't put 9s in any of those. So there's 9s here. So what can this be? 3, 4. That's it. Because it can't be 1, 2, 5, 6, 7, 8, or 9. So that's a 3 or a 4. These are 1, 3, 4, 6, I think. And these can't be 3 or 4. This can't be 1 or 4, and this can't be 3. So we still don't have this thing figured out, I don't think. Unless I'm just missing something, which is entirely possible. But 8, 8. So we have an 8 up here. We have a 9 in here somewhere. So there's an 8 up there. So let's see. What are these options? These are 3, 7, 8, and this one can't be an 8. So there has to be an 8 in there. 3. Oh, this one can't be a 3. These are 6, 7, 8, and 9, and this one can't be 7, 8, or 9. This is a 6. That's a 1. This is not a 1. These are not 6, so that's 7, 8, 9. Okay. Oh, and this this is the only one left in the box, so that's a 5. These are 3, 4, 6, 7, and 8, I believe. Oh, they can't be 3s. This can't be a 3 either. Oh, look. Can't be a 3. I was missing something. 2, 6 pair gives us a 3 there. So we can come back over here and say that's a 3. These are not 3s. Okay. Let's see. What else can we get now? Is there anything we can do over here on this puzzle? So we know there's 2s in there. All right, what are the options here? 3, 4, 5, and 9. This can't be 4 or 9. This can't be 5. I'm going to start filling in the edges here. 2, 3, 5, and 6. This can't be 2 or 5. This can't be 6. What are these options here? These are 1, 5, 6, and 8. This one can't be 1. This can't be 6. Neither one of these can be 8. This can't be 8 either. So the 8 has to be down here. Could have had that just from normal Sudoku, actually. That's okay. This one can't be 5. These are 3, 4, 6, 9. These two can't be 9. This can't be 4. This one can't be 3 or 6, so it's a 4. 4. So we have a 3, 6, 9 triple there. 3, 9 pair gives us a 5 and a 4. These are not 5 now. 3, 9, 3, 6, 9. This one, oh, this one can't be a 3. Because there, so these are 1, 2, 6, and 9, I believe. 2, 6, and 9. These are 3, 6, 7, and 8. 3, 6, 7, and 8. Which this can't be 8. This can't be 6. This can't be 8. This can't be 3. So it's a 7 or an 8. Okay. Let's go across the bottom. Why not? 1, 5, 7, and 9. These cannot be 5. This can't be 1, 5. This can't be 1 or 9, so it's 5, 7. These are 2, 4, 5, and 7, I believe. I'm probably missing something obvious on this one too, but I'm going to jump back to the other one and see. I was making more progress there. Let's see. These are 1, 3, 6, and 7, and these two can't be 7s. This one also can't be a 3. This can't be a 1. So we get a 3, 6 pair in the row there. This one can't be 6 or 3. So we have a 3, 6 pair. So let's look at this row. So 2, 5, 8, and 9, I believe, is what's left. This can't be 8 or 2. This can't be 2. This can't be 8 or 9 or 5. This is a 2. 2. So we get 5, 8, 9, which means there's an 8 in here, which we knew from normal Sudoku anyways. What are these? 3, 4, 8, 9? Oh, and look down here. This can't be 3, 4, or 8. This is a 9. 8. This is not 8, 9. That gives us a 3, 4 pair there. That 8 gives us a 9 here. Which means this is not a 9. What's left in here? These are 1, 3, 4, I believe. This one can't be 3. 2, 6. Okay, so the 6. What's left here? 1, 6, and 7. And these two can't be 1s. Yep, so this is a 1. That gives us a 6, 7 pair, which is going to give us the 2 and the 6. So now we can go back to the other puzzle, fill in the 2. That's helpful. But I'm going to keep going with this one because I'm making good progress here. 7, 2. These are 1, 5, and 8. This one can't be 1 or 5. This one can't be 1. 5, 1. This is not 5. Let's see. Let's fill in our... We got to update our pencil marks up here at the top with the stuff we get at the bottom. Oh, this can't be 4. This could never be a 4. That was a given. 7 down here gives us the 3 there. And that gives us 6 and 1 and 3. This is not a 3. The 1, 4 pair gives us a 6 there. This is a 4 and a 3. Now we're getting somewhere. 4 and 1. These are 3, 5, and 9. This one can't be 3. That gives us the 3 there. These are 2, 5, and 9, I believe, and this one can't be 2, so this has to be the 2. This can't be a 9, so that's the 5, 9, 5, 8, 9. All right, what's in here? 4, 6, and 7. This one, 6 or 7. That's not an 8. Those are 6, 7 pair. They're 4, 6, and 7. 4, 6, 7. We got 4, 6, 7 triple there. This is a 9. 4, 6, 7, 8. 6, 7. 4, 6, 7. I'm missing something. What am I missing? Come on. 8 up here. 6, 7 pair. There's 4s in here. Oh, I know what I'm missing. That's right. Oh, I know what I'm missing. Yep, this was a tricky thing that I threw in there. Just kind of to mess with people, actually. But, man, that's really bright coming in there, isn't it? we'll close that curtain. There we go. Now it's brighter over here. So now we gotta close this curtain a little bit. There we go. I'm gonna come back to what we're missing here. We're gonna go to the other one and finish solving it as much as we can, and then you'll see what we're missing. If you don't already see, you may already have seen it, but if you don't, we'll get to that. Okay, so where do we need to finish solving this one? Let's see, we had a 3-9 pair here. The 2. Did that 2 do anything for us? We got the 2. 2, 2. We know there's a 2 here. There's a 2. Oh, there has to be a 2 here, right? Because look, the 2's in the middle from there, and then the 2 over here. It gives us a 2 right there. Which means this is a 2. We have a 3-6 pair. Okay. These are 1, 3, 5, 6, and 8. This one can't be 8. This one can't be 6. I didn't do too much for us, did it? 2, 4, 9. Oh, this can't be a 9. Look at that. It's looking right at a 9. That's a 4, 2. I am just not scanning very well today, am I? I say today as if that's unusual, but, you know. The 9 gives us the 3 and the 9. And this is not a 9. Okay. 2, 4, 9. Okay, so what's down here? These are 1, 3, 6, 7, 9. I believe this one can't be a 9. So the 9 has to be there. There's a 9 in the middle here. The 9's in the middle here can't go there. So that gives us this. This is now a 9. And now the 9 has to be up there. These are 1, 4, 5, 6, 7, I think. This can't be 1 or 4. This can't be 5, 6, or 4. This is 1. We have 1, 7, and 8 in the column there. This can't be 2. I mean, look, there's a 2 right there. 4, 5, 7. This can't be 1. 5, 6. These are 1 and 3. We have a 1, 3 pair there now, so this can't be 1. That gives us 7, 8 pair in the column. That's a 1 there. This is not a 1. That gives us a 1 down here. These are not 1s, so this has to be a 1. That gives us 3 and 1. This is not 3. This is not 5. So we have 3, 8 for the row, and there's an 8 down below, which gives us the order of those. 3 and 8. This is 3, 5, and 6. 3, 5, 6, 7. This one can't be 6. Oh, the 6 over there. So it's 3, 5, 1, 6. These are 5, 7, and 8. This one can't be 8. That 6 gives us the 7 and the 3 and the 6. And 5, 7 gives us the 4 and the 6. This is 4. Now, you're going to think, oh no, we have a deadly pattern. Yes, we do. That's okay. This is an 8, a 7, and a 5. You'll see why. 3, 6, 7. This is not 7 or 8. 3, 6 gets resolved like this. So we have everything but this deadly pattern, which would be a problem, except if we go back to our Dropbox, our puzzle here, you'll notice there is now we've been collecting all these symbols, right? We've got the scream, the house, the apple, the brush. This modern art looking thing is another one of those symbols. It's obviously going to have to be the same digit. And so that's, let's see, in the puzzle with the 1 in the corner, it's in the bottom right. The puzzle with the 5 in the corner, it's in the upper left. So this one, the 1 in the corner, it's this cell down here. So this is, let's make it that color. This has to be the same digit as this. Oh, because that is the, the symbol that we're going to need for the special collection room. And so it's either 7, 8 on the one puzzle, and it's 5 or 7 on the other puzzle, so it has to be 7. That's the only one, so it looks good. Now we can finish off the other one, so we get the 7, 8, 7. This is not 7, that's a 6, 4, 8, and that is going to allow us to finish off the puzzle. So that was a little bit tricky. It's definitely something, if you're used to puzzle hunts, that might have seemed just obvious to you. Well, of course, these two have to be the same. But, when you get stuck and it looks like you might have deadly patterns, look around for where you might be able to find something that could help you. So that gives us, I'm going to call that modern art equals 7. That gives us a 7 for the modern art. Okay, now we're going to go back to our Dropbox. Actually, we need hold on, sorry. We need to figure out the password for the next one, don't we? Okay, back to this one, the killer. So we need the digits in the centers. And again, if you look at the pattern of it, it's actually the right one and then the left one because of the pattern of these. So it's the center of the one with the modern art in the upper left, and then the center of the one with the modern art in the lower right. So let's go back to those. And so it's going to be this one and this one. So 75 is going to be our password for the killer puzzle, I believe. Let's try that. Let's go to the killer. 75, submit, and we get into the killer puzzle. All right, very good. And then I take a break to stretch. All right, so the killer puzzle. This one, we're going to zoom in a little bit. So I want to look at a couple of things. First of all, let's look at the clues to the next puzzle. So the clue to the arrow puzzle, well, we can look at the clue to the clone puzzle, which we just finished, right? And again, not needed to solve this, but a help if you're struggling. You could backtrack and say, okay, the clue to I know the password to the clone puzzle, and so maybe I can use this to help me because it was 34545. So we look at this pattern and it's a little weird. You got all these little lines, kind of concentric little arrow things pointing to the middle. Now if we look at the puzzle here, though, you'll notice a bunch of these arrows, so it's the same pattern. And so what that's telling us is we have the digits at the corners here, A, B, C, and D, and then the E is in the center. So theoretically, what we could do is we could start this puzzle just by filling in 34545 in those positions if we wanted to. You don't have to do that. It's not necessary to solve this puzzle. Because if you came from the other direction, of course, you wouldn't already have those numbers. But if you're going this direction, that might help you. Now, if you're coming from the other direction, you could potentially use this one to help you. But this one, we've got kind of this weird plus shape thing here with these circles. And if you look back here, you'll notice there's also kind of this plus shape in the grid with empty cells on the outside. So the clues to the next puzzles, either direction, is sort of using the geometry of the cages here. So what it's telling you is it's these 5. And you could just type in the 5 digits. You would find that it doesn't work. You might have to try a couple things. But what it's a plus shape, so it's trying to tell you to sum the numbers. So you add those together to get the total. And that's going to be the password to the arrow puzzle. Now, there's one other thing that's important to note. It's always good to look around. Now, we've been going through several of these, and they all look the same, right? We've got this bench down here. We've got this sign. But we haven't seen any that had Braille on them. Now, you can look up the Braille. Obviously, I don't expect you to read. I mean, some of you may read Braille, and that's great. But I wouldn't expect most people to be able to read Braille. I can't read Braille. But you can Google it. You can find the charts. And what you're going to find is it says R7C6 2. Or maybe 2 R7C6. Something like that. Somehow it's going to tell you that row 7, column 6 is a 2. Now, the interesting thing here on this puzzle, I think, is row 7, column 6 is a 2, right? Now, this puzzle has a unique solution without that knowledge. So theoretically, it would be possible to solve it without that. I I was not able to solve it without knowing that's a two. I think computers can verify it's a unique solution, but you need the two to solve it as a human without bifurcation and stuff, obviously. Um, so this was a clue that was very important to be able to solve. You had to find this one. So we also have this little painter's palette thing here. That's one of our symbols from the special collection doors. So let's go ahead and open up the killer puzzle in the online version. Let's see, where did it go? Here we go. There's the killer. So we know that row 7, column 6 is a 2. That's what we get to help us out here. Now we could fill in the 3, 4, 5, 4, 5, but we're not going to. What we're going to do instead is we're going to start looking for places where things are limited. Now 22 in 3 cells. Let's see, 8, 7, 6 is 21. So you know you have to have a 9, right? We have to have a 9 in there. Now that's going to leave 13. So 9, it's got to be 8, 5, or 6, 7 with the 9. This one's the same way. It has to have a 9. 9, 8, 5, 6, 7. So let's see. 22. Now we could try some things like some geometry things, like 22 plus 17 is 39, and we know the whole box is 45, so these 3 actually have to be 6. They have to be 1, 2, and 3. That's the only way to make 6 in 3 cells. Okay? And we know there's a 4 in here now because there's no 4 in here. So it's going to be 4 with 5, 9, or 6, 8. And this is, or sorry, with not 5, 9, or 6, 8. 5, 8, or 6, 7. Just like this one is 9 with 5, 8, or 6, 7. Okay, but let's do up here. So 20 and 15 is 35. So these have to be 10, right? 10 and 3. You can do quite a few options there, actually. But, oh, this is not a 2, right? 10 and 3 has quite a few options. So let's come back to that one. Up here, 22 and 13 is 35. So again, 10. So not super helpful. This one, though, 20 and 17 is 37. So this one has to be 8. So it has to have a 1. And it has to be 1, 2, 5 or 1, 3, 4, right? Okay. Let's see, what can we figure out? So 1, 2, this can't be a 2. So let's go back up here to this. This has to be 10. Those 3 have to be 10. So can you not have a 1? Is that an option? Yeah, you can do 2, 3, and 5, right? 2, 3, and 5. If you don't have a 1. So there has to be a 1 or a 2 in there. Pause for a phone call. All right, I'm back. While I was on the phone, I remembered what I need to do here. So there's an important thing to look at. So I was looking at the 45s in the boxes, but what we need to look at is the 45s in this row 5 and column 5. So 11 and 12 is 23. So we need 22 on the outside here, which, like we said up here, is 9 with a 5, 8, or 6, 7. Now 18 and 19 is 37, so we need 5 on the outside here. Now the biggest number you can put in a 3 cell, did I say 5? We need 8 on the outside here. The biggest number you can put in there is a 5, and the smallest we can put in this one is a 5. So that has to be a 5, which means these are 1 and 2. And now these have to be 8 and 9 because 5, we need to have 22. It's got to be 17, so 8 and 9. And now this is the important part because now we have a 1, 2, 3 triple. The minimum you can put here is 4 and 5, which is 9, which gives us 1 because those 3 have to equal 10. And now we can't put a 1 in any of those. We also have a 3 down here because the 1, 2, 3 triple. So this is not a 3. So these can't be 1. This one could be 1, potentially. But that would put a 2 and a 1, which would get rid of 1s here. It would put a 1 there. So if this is a 1, this would be a 1. And then you couldn't put a 1 over here. And one of these has to be a 1. So you can't actually put a 1 there. You can't put a 1 up here. So these can't have 1s. They have to be 2, 3, and 5, which gives us this as 6, 7, 9. These are 1, 4, and 6, which should add up to 13. It does. Very good. And now this one down here was either 1, 2, 5 or 1, 3, 4, right? Well, if it's let's see, can we do 4, 5? Yeah. Okay. So if it's 1, 4, 5, or 1, 1, 2, 5, sorry. These are going to be 1, 2, 5. That's going to be there. This would be 3 and 3. Because if these are 1, 2, and 5 down here, then these 3 are also 1, 2, and 5, which takes away the 2 and the 5, makes those both 3s. So this cannot be 1, 2, 5. This has to be 1, 3, 4. Okay, and now let's see, 1, 3, and 4, and a 2. So what can we do? We know there's a 3 here. I feel like we can do something else here. One, 2, and 3. So the 2 is down here. So 1, 3, 4. 1, 2, 3, 4, 5. So there's definitely a 5 up here. This is not a 5. I was thinking we could get more than that, but maybe not. Okay, so we can't use 1, 4, or 5. So 2, 3, 6 is the minimum we can do, which is 11. So there's quite a few options there. But the 2 can't go in the 20 cage, right? And neither can the 3. The 3 can go in the 20 cage. 3 would have to have 8 and 9. The 2 can't go in the 20 cage, though. So the 2 is in the 15 cage. So it's 2. We need 13 more, which can't be 9, 4. Can't be 8, 5. It has to be 6, 7. So it has to be 2, 6, 7, actually. Which gives us 3, 8, and 9 here. Okay? The 4, 5 up here means this is not 5 or 4. So there's a 4 in one of these. Because remember, this is 4 with 5, 8, or 6, 7. Oh, the 1 here. That's what we needed to see. The 1 here gives us the 2 there. This is 1, 3 now, which makes this a 2 and a 1. I thought there was a way to get the rest of these figured out. That puts a 1 there. And now this 3, 4 here means these are not 3. So this is 2. This is not 2. Oh, wait. Nope. Sorry. That's a 3 because the 2, 5. Yep. There we go. That works. Okay. So from here, we're going to go. So I'm going to look at 2s. We need to have a 2 over here, but it can't be there. So there's a 2 in one of these. Now, can you put a 2 in a 20 cage? No, because the other 2 would have to sum to 18. So you can't do that. So that gives us a 2 there. And so now we can't have 2s in those. Can't have 2s in those. So there's a 2 in one of these. Now the important thing to look at is up here. We have a 2, 6, 7, 9 quadruple. So this can't be 6. This can't be 9. But more importantly, that 2, and this can't be 2. But this 2, 6, 7, 9 quadruple, more importantly, tells us the 9 has to be in one of these 2. And therefore, you can't put a 9 up here. And so now where are you going to put an 8 and a 9 in row 1? The 8 and the 9 both have to be here in box 2. So this cannot be 8 and 9. If this is a 2, these have to be 8, 9. But you can't put an 8 or 9 there, so this cannot be 2. So that gives us a 2 here. That gives us a 2 up here, but again, a 2 here would force an 8 or a 9 right there. So this is a 2. And now that we have our 2 here, these have to sum to 9. They can't be 1, 8. They can't be 2, 7. They can't be 4, 5. They have to be 3, 6. And that leaves 1, 4, and 7, which hopefully adds to 12, and it does. Good. All right, so we've got a lot of our 2s. We know there's a 2 up here. Now the 2 could be here though, because you could put 8 and 9 down here. The 2 couldn't be in either of these cells in the 19 cage, but it could be right there. So, the 2, 6, 7, 9. Again, quadruple makes this 3 and 6, which gives us an 8 there. That's a 3 and 9. The 6 here. Oh, we just broke it. What did we do? Uh-oh. Oh, no. I broke my own puzzle. Of course I did. Why wouldn't I? Seems perfectly reasonable, right? So those two have to sum to 9. They can't be 1, 8, 2, 7, 4, 5. They have to be 3, 6. 2, 6, 7, 9 gives us 3 and 6. But these... Because I did that wrong. That's what I did wrong. This is not 1, 4, 6. Why did I get 1, 4, 6 in there? That's completely wrong. This is 1, 4, and 8. 1, 4, and 8. Okay. I can't do math right. 1, 4, and 8 sums to 13. And there's already a 6 in here anyway, so it doesn't make any sense. Okay, otherwise we're good so far. Everything else we did so far was good. Okay, the 2, 6, 7, 9. Yep, okay. So the 8 is not in here. The 8 is down here. 3, 9. Okay, I think we're good now. All right, so this is 1, 4, and 7, just like we said. A little bit of brain lapse there. Okay, so we've got 1, 2, 3, 4, and 5. These are 6, 7, 8, and 9. The 2, 6, 7, 9 quadruple again. Where are we going to put the 2 in there? It has to be right here, right? And so now, does that help us with our 2? No, one of these is still a 2. The 1 down here gives us the 4 and the 8 and the 1. And now these are 1 and 5. 6, 7 pair up here. So these are 2, 4, 5, 8, 9, I believe. They can't be 5s. So there has to be a 5 in one of these on the outside edge. These are 2, 4, and 7. Yeah, 2, 4, and 7. This one can't be 2. So if this is 7 in the 10 cage, you'd have to have 1 and 2, and you can't have a 2. So this has to be 4. This is not 4. That 4 gives us 5, 4, 5 gives us the 2 and the 5. This is not 2, so it's 7. And now we need 12 in here. Can't be 4, 8. Let's see. It could be 9, 3. It can't be 5, 7. So it has to be 9, 3. Like that. These are not 9s. These are... What? Oops, sorry. What are these? 5, 6, and 7. This one can't be 5. So there's a 5 in here for sure. So there's 5. We need 15 more. So it's got to be 5, 6, 9, or 7, 8. That's an 8 or a 9. And this, the 2 and the 17 means these have to be 6, 9, or 7, 8, right? So we have 6, 9, or 7, 8 here, and then we have a 5 over here with a 6, 9, or a 7, 8. Okay, 6, 7, 8 triple. So these are 3, 4, and 5. There's a 6, 7, 8, 9 quadruple here, and the 8 has to be down here. So this can't be 8, which means that can't be 7, because these two have to sum to 15. This can't be 5, right? So these are at least 9 and at most 11. So this is 9, 8, or 7. It can't be 7. So it's 9 or 8. Let's see. What else can we do? 8 or 9. 8 has to be in one of those. Oh, the 1 here gives us the 3 and the 1. That 3 gives us the 4 and the 3. So this is not a 4. So the 4 now has to be in here, because the 4 has to be in this cage. So this is not 4. This is not 1. This is 2. Oh, this one can't be the 2. This is the 2. 4 there. So we have an 8, 9 pair in the middle there. That's good. We kind of expected that. These are 6, 7, 8, 9. This one can't be 9. So the only place for a 9 in column 9 is right here. And that puts a 9 in the middle here in one of these. Now, if this is the 9, then you have 3, 7, or 4, 6, which seems fine. If this is the 9, you would need to have 10. It couldn't be 1, 9, 2, 8. It would have to be 3, 7, or 4, 6. Right? No, if this is 9, sorry, if this is 9, this is 9, which is 3 and 6. That's the key. If this is 9, this is 3, 6. If it's 8, you have 3, 7, or 4, 6. If this is 9, if this, then you'd have 8 over here. You'd have to have 11, which would not be 9, 2, 3, 8, 4. I don't think that's going to work. So if you have 9 here, it has to be 3, 6. So you have 3, 6, 9. These would be 4, 7, and 8, which would work to 19. Okay, that does work. Never mind. The 4 can't be here, so the 4 is down in one of these two. So this is not a 4. What about, can we do anything with this 11 cage here? Or maybe the 10 cage, the 4. So you need 6. It has to be 1, 5. It can't be 2, 4. It has to be 1, 5, doesn't it? And it's this order because of the 5 there. This is not a 1. That gives us the 1 down here because the 4, 7 pair there. 1, 5. This is not 5. These, oh, the 3 gives us the 4. Should have had that. 3, 5. This is 6, 7, and 8. So we have to have a 1 here. Okay, so this is 9, because we have 2 already. It needs to be 11 total. Can't be 1, 8. Can't be 2, 7. Can't be 4, 5. It has to be 3, 6, and the 3 there. It's going to give us the order of those. So these are 4, 6, 7, 8, I believe. So if this is 9, you'd have to have 10, which would have to be 4, 6. Oh, we have a 3 here now, right? So this is 15, so it's either 6, 9, or 7, 8. So the other one is 15 with a 4, so there has to be a 4. And it has to be in one of these two. Can't be there. This is 4. So this is either 6, 9, or 7, 8. 7, 8, 9. This is 4, 8, 9. It can't be 7. It can't be 9. 4, 8. Oh, this can't be 6. So we have 4, 7, 8 here. So this is 2. These two have to equal 10. They can't be 8 and 2. So this has to be 4 and 6. It gives us 7 and 4. This is not 7. So these are 8 and 9. This is not 8. So these are, yep, 6, 9, or 7, 8. Just like we figured. The 1 here is going to give us 5 and 1. My watch is buzzing like crazy. Getting lots of messages. All related to the swim meet happening today, I think. My son has a swim meet. Actually, no, not today. Tomorrow. He has a swim meet tomorrow, but they're getting ready for it today. These are not 7. This is just kind of finishing off with normal Sudoku at this point now. Oh, we know there has to be an 8 here because of this, so this can't be 8, so that puts the 8 down here. Where's the place to look? We've got the 3. Oh, the 3 here gives us 9 and 3. So these are not 9s. These are not 5s. They're not 8s. Those are 6, 7. There has to be a 9 in this cage. It has to be there. 6, 7 pair gives us the 8 there. That's not an 8. This is not. This is a 5. 8. The 9 on the other side gives us the 8 there. So now This one it has to be 15, so you can't have a 7. It's got to be the 6, 9. That's the 5, 7. Gives us a 6 there. 7. This is not 7. This is not an 8. 6, 7, 8, 9, 8, 9. We've got a bunch of 8, 9s in here. Somewhere it's going to resolve. Oh, the 6 here gives us 7, 6. That 7 is going to give us 5 and 7. And the 6 over there gives us the 9 and the 6 and the 5. And then, oh, right. This is resolvable because we have the 3 and the 6, which is 9, and it needs to be 18 total. So 9 and 8. Maybe there was a way to do it. 9 and 8. The 6 down here gives us 7 and 9 and 6 and 7 and 6. 7 and 6. Looks good to me. All right, so there we go. That was the killer puzzle. Now, we need to go back and look at... okay, so we had this palette thing here, right? Which is in row 6, column 2. So if we go back to the puzzle, row 6, column 2 is a 5. So that palette is a 5. So let's add that to our notes here. Palette? Not sure on the spelling on that. We'll just call that close enough. Palette equals 5. All right, so that's a 5. Good. All right, I'm going to go let my dog in before I move on to the next puzzle. All right, so the next puzzle then, let's go back to where we were on the killer. Okay, so if we zoom back out a little bit, we'll see we can go to, we've already been at the clones, so we want to move on to the arrow puzzle. Now, as I said, the clue to the arrow puzzle, we're using the 5 digits out here, and you could try some different things, but hopefully eventually you at least try this if you don't realize that the plus shape of the grid is telling you to sum those 5. So let's go back to the puzzle. Here we go. And we need to sum these 5 digits. So we have 8, 9, 1, 2, and 5, which sums to 25. So 25 is going to be our password for, where'd it go? There we go. Sorry. The arrow puzzle. Password for the arrow puzzle. So let's go back to our list. Arrow puzzle, 25. Submit. And there we go. We're into the arrow. Now, there are a few things to note. On the arrow puzzle because, like I said before, you kind of sort of get lulled into a little bit of a sleep, I guess, because you're like, oh yeah, I've seen this. We have the bench, we have the sign. If you don't see the braille on the previous one, right? Or if you're coming from the other direction, you wouldn't have seen the braille yet. And we've got our signs leading to our different things. Yep, okay. There is this sign over here that jumps out. Please note, B greater than Y. Well, it's not too hard to figure out. That means blue is greater than yellow, right? But we have 2 yellows and 2 blues, so I'm not sure how that works yet. But there's something else important to notice. Now, again, kind of like the 2 on the killer clue, this is not required for a unique solution on the puzzle. But it greatly helps with the solve. So if we scroll down, right here on the bench, it says Vitruvian is not 7. So, and the Vitruvian man is our symbol in this puzzle that we're going to use on the special collection door. So right there on the bench, hidden in plain sight, is a little clue that says Vitruvian is not 7. Okay, now let's look at our clues to the other rooms quick. So going back to the killer, which we were just in, we have a sigma, which is often used to mean sum. And sum, this is not the sum of 0 to 7. It's not the sum of 0 minus 7. This is the sum. You notice this isn't quite, like the font looks a little funny. This doesn't really look like a 0. That's a circle. It's saying the sum of the circles in the arrows minus 7 is going to give us the killer. And so again, theoretically, you already know the password to the killer was 75. So you know the sum of the circles here has to be 82. So, and a little behind the scenes, This was originally just supposed to be the sum of the circles, but I added an extra arrow to the puzzle to make it a little bit easier to solve. Even though it wasn't necessary to solve, it made it a little easier. And then I had to add the -7 so that the sums worked out. Anyways, the chess puzzle, the clue to the chess puzzle here. It's not too hard to see, kind of we've got this X in the grid here. That's an X, and then there's this arrow going through the X, which is this arrow here. And so we're going to use these 4 digits here, 1, 2, 3, 4. Now, if you were coming from the other direction, again, not necessary for the solve, but you could use that information knowing the password to the chess already, and you could fill those 4 digits in potentially. But not necessary to solve this. So, all right, let's jump over to the online solving version of the arrow puzzle. Here we go. All right, so arrow puzzle. What can we do? Well, so right away, you'll notice there's these overlapping ends of these arrows, which happen to be the blue and the yellow cells. So those are going to be, that's a clue that you're going to need those right away probably. So these are all 3-cell arrows. So we know that they are 6, 7, 8, or 9, right? But we also know these 5 cells, any 5 cells really, if they're unique digits, are a minimum of 1, 2, 3, 4, and 5, which is 15. And there's going to be a double counting here when you go with your 2 arrows, because this is in both arrows. So 15 plus 1, the minimum here is 16. So there's no way we can have a 6 in any of these, because the minimum is 16. Now, we know the Vitruvian is not 7, so this is not a 7. Okay? Now, we can also think about, well, the maximum we can have is 17, right? The minimum was 16. The maximum is 17. So 16 was if we double counted a 1. If you put a 2 in there, now you're at 15 plus a 2, that's 17. So this has to be a 1 or a 2. You can't do a 3 or you'd be too big. So these have to be 1s and 2s. And now this is where the blue greater than yellow comes in. Now, it's not clear from the sign. Is it each blue is greater than each yellow? Is it the sum of the blues is greater than the yellows? Is it the ones across from each other? But it doesn't really matter. Because if you just try those options, any way you look at it, any way you interpret blue greater than yellow, these have to be 2s and these have to be 1s. Because if these aren't both 2s, if they're, say, 2 and 1, then these other ones are 2 and 1, and now the combined blues are not greater than the combined yellows. So, any way you interpret that sign within reason works out to these are 2s and these are 1s. Okay, perfect. Now, if this was a 7, let's think about this. Could this be 7? Could this be 7? Well, you'd have 1 and 4 here. 1, 2, 4. The minimum you could put here would be 3 and 5, but 2, 3, 5 is 10. So that doesn't work. So you can't have a 7 here. What about over here? 7. So this would be, again, 1 and 4, 2, 3, 5, same problem. So this can't be 7. Oop, so it's an 8 or a 9. Now this one, same problem here. You'd have 1, 4, 2. This would be 3, 5. So you can't put a 7. So these are 8s and 9s in these 4 corners. And so these 3 are pretty easy to remove the 7 from, like I just showed. Relatively easy to understand, at least. This one is harder to rule the 7 out of. You can do it, but it tends to kind of end up being bifurcation. And so that's why there's that hint about this is not a 7. It's not necessary to prove a unique solution, because if you try and put a 7 in here, it's not going to work. It's going to break the puzzle. But not right away. It's going to take a little bit of time. So that's why that clue was in there. So these are 8s and 9s. So we know it's going to be 9s at one corner and 8s at the other corner, somehow. One way or the other, right? So let's see. Let's do some stuff in the middle. Now, these being 8s and 9s, we know that the biggest we can put on an arrow is a 6, right? So we can't put 7s anywhere in here. So where are 7s going to go in columns 2 and 8 and rows 2 and 8? They've got to be... somehow in these, right? And so we can't put a 7 in any of these other cells in those boxes either. So the 7s have to be somewhere in these. Okay, so what that tells us is these cannot be 7s. All right, so let's look at the middle of the grid. This has to be at least 3 because we've got 1 and 2, right? What's the most this could be? Well, we have to have 4 different digits added to it to still get, a maximum of 9. So one of these is going to have to be at least 4. So 9 minus 4 is 5. So this is 3, 4, or 5. Okay? That's all that can be. If this is a 6, then you're going to have to add a 4 somewhere and you're going to get 10. So this is 3, 4, or 5. We're adding at least 1. So these have to be at least 4. So these are 4, 5, 6. They can't be 7s. 8 and 9. Remember, we can't have 7s in these because of the 7s being on the outsides there. So let's see. These can be a maximum of 6 then, right? Because 3 and 9 could give you 6. So these are a maximum of 6. Now let's just think about, does 5 work? Well, if you have 5, you'd have to put 1, 2, 3, and 4 out here, right? And what are these going to be then? 6, 7, 8, and 9. But you can't put a 7 in there, so this can't be 5. Now, if it's 4, you're not going to be able to do 4, so it's going to be 1, 2, 3, and 5 are going to be what you have to put here. And you're going to get 5, 6, 7, and 9. Again, you can't do a 7. And so there's 4 digits that are bigger than 4 that you can use, 5, 6, 8, and 9. But the problem is the 8 would require a 4 and a 4 to get to 8. So you can't do 4 either. This is a 3. These are not 3. So now we have 3. We need to use 4 bigger digits out here. They can't involve a 7. We also can't use a 6 because 6 would be 3 plus 3 equals 6. So these have to be 4, 5, 8, and 9. And now you might think these could repeat, right? But the problem is these 4 can't repeat. And you're adding them to 3, so therefore these 4 also can't repeat. So 4, 5, 8, and 9 gives us 1, 2, 5, and 6 here. These are 4, 7, 8, and 9. Now the only way that this arrow works, this is actually the arrow I added later. To make the solve a little bit easier. This arrow is not necessary for the solve, but helps a little bit with one of the big steps here in a minute. So the only way this works is if this is 4 and 7. 8 and 9. There we go. Now here's the key part, okay? Remember, we said you're going to have 9s in opposite corners and 8s in opposite corners, one way or the other. Now, if this is 8, let's say the 8s are this direction, right? What's going to be on the arrow here? Well, it's going to be 2, 5 or 3, 4, right? But the problem is if you do 2, 5 down here or over here, what goes over here with the 9? Because the 9 needs to be 2, 6 or 3, 5. So you can't do it. So the 8 here, if that's an 8, these have to be 3, 4. Okay, fine. But if this is a 9, this has to be 3, 4 to go with the 2, 6. Because this 8 with a 2 is going to be 1, 5. So you can try different options, but you're going to find this is required, okay? So the 3, 4 here and the 3, 4 here, the problem becomes right here with this 4. You can't do it. Because now you've got 3, 4 in 3 cells. So basically what that says is the 8 cannot be down here. Now that is findable without this arrow here, without putting that 4 there. It just takes a little more finagling. Up here you find that you have 1 and 5, and you remove 1 and 5 from these, and then it also removes, it just doesn't work, but it's a little harder to see. So, but ultimately these are 9s, these are 8s, because of that 4, and you'd end up with 3, 4 in both of these cells if this was 9 and 8 the other way around. Okay. So what that tells us is, so we have 1, it needs to be 17, so it needs to be 1, 2, what is it, 1, 2, 3, 4, no, 1, 2, 3, 5, 6, I think is what we need to use, right? I don't know. Anyways, 1, this has to be 2, 6, or 3, 5. We'll just do it the other way. Because my brain's not doing the math right. Because I've done like, I don't know how many of these puzzles now. 3, 4, 5. I'm on like puzzle 7 now. Um, I probably shouldn't have done them all in one day. So if this is 2, 6, this would have to be 3, 4. If this is 3, 5, okay, 3, 5 is the problem here. If this is 3, 5, this one needs to be 3, 4 or 2, 5. So this has to be 2, 6, which means this is 3, 4, and this is going to be the same way. 2, 6, 3, 4. And now the other way, this has a 2, so this needs to be 1, 5, which means this is 3, 4. This is 3, 4, 1, 5. Okay, now this can't be a 4, obviously, because of the 3, 4 there, right? The 2, 6 here. Now these two have to be different, which then means these two are the same and these two are different. So this can't be 2 or 6 because these two are a 2, 6 pair, essentially. So that's a 1 or a 5, which means this is 4 or 8. This can't be 5 or 9 anymore. This one, we took out the 4, so this can't be 1. This one can't be 8, so this can't be 5. This can't be 8, so this can't be 5. This can't be 9, so this can't be 6. There we go. Working our way down there. Now, one of these two is a 9, which means one of these is a 6. Oh, we have 3, 4, and 3, 4 here, so this can't be a 4, which means this can't be a 1. So the 1 is over here, which means this is not a 1. It's a 5. This is a 1. This is a 1. This is 4. Not 1 or 4. 2, 6 pair gives us a 5 there and an 8. Let's see the 1 here. 5, 1. Can we do anything else with those? That might be all we can do with that. These are 6 and 7. These are 5 and 7. I'm going to get rid of our 7s there. Now these are 6 and 7. These are 5 and 7. Okay, so that leaves 1, 3, and 8 here. This one can't be 1, and this one can't be 1. So it gives us a 1 there. Up here we have, oop, that was completely wrong. Just hitting buttons here. 1, 2, oh, seriously. 1, 2, and 5. There we go. So this is 5, 2, or 9, 6. The 2 here. Okay, so these have to differ by 2. So we can't do 1 and 3, obviously. So these have to be, this has to be at least 4, which means this is at least 6, but we can't get bigger than 8. So this is 4, 6. It could be 5 and 7, except we already have a 5. So this has to be 4 and 6, which gives us 3 and 4 and 3 and 4 and 3 and 4. Uh-oh. Oh no, what'd I do? Uh-oh. I broke it. How did I do that? Because I did it backwards. I did it backwards. I put 4 and 6. It's the other way around. 4 and 6. It's right. I just had the circle at the wrong end. Like I said, I've been doing too many of these puzzles today. All right, there we go. That works. I was worried there for a second. The 3 there gives us 4 and 3. Okay, now this one, can we do anything with this? So this is, let's see, it can't be 1, 3, 4, 5, or 7. So this is 2, 6, 8, or 9. It obviously can't be 2. So this is the circle. We're going to remember that this is the circle this time. Has to be 6, 8, or 9. This would have to be 5, 7, or 8. It can't be 5, so this can't be 6. So it's either 7, 8, or 8, 9. Okay, these are 1, 7, 8, and 9. These two cannot be 8s. These two cannot be 7s. So we get a 1, 8, 9 triple there. So this is a 2 or a 6, which gives us a 2, 6 pair. That's interesting. Oh, we also have a 2, 6 pair here. So these are 3, 5, 7, 8, and 9, but you can't put the 8 and the 9 in the middle here. This one could be 8 or 9, though. 3, 5, 7. They can't be 3s, so that's a 5, 7 pair. This is not 5 or 7. So we get 8 here because of the 5, 7 pair. That puts a 9 there. That gives us a 3. This is not 8, so the 8 in the box has to be up there. These are not 1s because of the 1 down here, so we get a 1 there. 6, 5, 7. Looking good. But we know that the 7s have to be in one of these two. So this actually, so there's a couple ways. If you forget about that, this 5, 7 pair is going to give you the 6 there. But actually we know this can't be a 7. So it has to go that way. That's going to give us 7 and 6 and 7 and 6 and 7 and 5 and 5 and 7. All kinds of stuff. That 5 is going to give us the 9 here. 7, 9. This is now a 6. This is a 2. That's a 5. This is 6. 2, 6. This is not a 1. This is a 2 and a 5. 1, 2. These are 3 and 6 here. Oh, sorry, 3 and 6. Oh, the 2 here gives us 6 and 2, and that 6 is going to do the 3 and the 6, and the 3 will give us the 8 and the 3. This is 9 to finish off the row. These are 2 and 4, and they have to be in that order, and that 2 gives us the 1 and the 2. This is 4, 8, and 9. Can't put the 4 in the middle here. These are 1, 3, and 8. Can't put the 3 in either of those, so that's a 3. The 1 can't be here. 8, 1. That 8 gives us the 9. These are not 9. These are 6, 7, and 9. This can't be 7 or 9, so it's a 6. We're going to get a 5 to finish the row. These are 2 and 7, I believe. The 2 will give us 7 and 2. That 7 is going to give us the 9 and the 7. The 9 will give us the 8 and the 9. And the 8 will give us the 4 and the 8. Looks good to me. Timer stopped. All right, so there you go. That was the arrow puzzle. It was not an easy arrow puzzle. So with the testers, all said this was the hardest puzzle in the hunt. So if you had trouble with the arrow puzzle, I know a lot of people did. Don't feel bad. It definitely was the hardest puzzle in the hunt. There was some interesting things there that you had to try and sort of look at. If it's an 8, it's 3, 4, and if it's a 9, it's a 3, 4, and those match up. And the 4 there, there's some things in there that you had to figure out. So definitely the hardest one in the hunt. But there we go. Let's go back and look at our thing here. Okay, so what did we need? We needed the Vitruvian, which was down here in this bottom left corner, which was a 9. So the Vitruvian is a 9. Let's add that to our notes. Let's see. Vitruvian equals 9. I think that's maybe how you spell Vitruvian. If not, that's how we're spelling it today. Okay, so back to, we need to look at the next, the clue. It was the 4 digits in the middle here. So 1, 2, 3, 4, sort of north, east, west, south in that order. So that is going to be 9, 7, 4, 8. So 9, 7, 4, 8 for the chess puzzle. 9, 7, 4, 8, submit. Here we go. Chess. All right, so this is a chess Sudoku puzzle. Now, the Thermo clue here, if you recall, we figured out the Thermo from the lobby. Man, that's really bright coming in there, isn't it? Put the curtain down a little bit so I'm not just completely blown out. Is that a little bit better? It's still really bright. I don't know where the light's coming from because I've got it all blocked. That's that side. It's backwards, so that's why I put my hand up to figure out which side the light is shining on. Anyways, maybe I can block it with this thing. Does that help a little bit? It's just bright. It's just bright, a bright sunny day. It's gonna be fine. Okay. So the Thermo, as you recall, we had the Hg, which we said was Mercury. Well, the clue coming from the other direction, Holst's third. You may not be familiar with this, but you could Google it. Gustav Holst wrote a very famous composition called The Planets, and the third planet in the order was Mercury. And you might think, why is the third one Mercury? Mercury is the first planet. But Holst wrote this a long time ago, and back at the time, I think it was pretty common, at least he believed, I guess. I think it was common belief, or not necessarily a belief even, but just to think about the Earth as the center with things revolving around it. And so he was doing it kind of in order, moving away from Earth. So Mars is first, and then Venus, and then Mercury. So that's why Mercury is third in Holst's planets, and that is a wonderful composition. So if you haven't listened to it, go check it out. But I digress. All right, the arrow puzzle. Now we already know the answer to the arrow puzzle. It is 25. So again, you could use that knowledge here because it's the crown jewels. It's the 2 jewels here. So we could put in a 2 and a 5, but we're not going to. So this is just a knight's move puzzle. Just a simple knight's move. Not simple, but I mean rules-wise are simple. Knight's move puzzle. The puzzle itself is not necessarily simple, but knight's move. So we can't repeat a digit a knight's move away. So this 2 can't be there. Obviously can't be down here. Can't be there. Can't be in any of those. And that is the extent of the rules. So there's a 3 down here. Let's see. We can fill in these 2. These are 3 and 4. We don't know which is which yet, but 3s tell us there's a 3 over here, and this 3 sees there, so that's a 3. That gives us 4 and 3. Okay, now the 1 can't be here or here because of this 1 and that 1. So there's a 1 over here, which means there's a 1 down here, but that 1 sees that, so that's a 1. Now there's a 1 over here. Knight's move removes it from that one. I guess we could fill in. There's only 4 options here. Let's fill those in. These can't be 9s. This one can't be 4 or 5. Okay, let's do these here. 1, 2, 3, 4, 9. These can't be 4s. This one can't be a 2 or a 3. Okay, so 3's up here can't be in any of those because of these 3's, and this one sees that, so it's got to be one of those 2. We've got 2 options though, so that's not quite helpful. 3's. There has to be a 3 up here. It's a 3 down here, and a 3 in here somewhere. Okay. Let's see. Where do we look next? 2's. Okay, 2's can't be in any of these because of these 2 2's. And this one is by knight's move, so it's one of these 3. But I don't quite see how that helps. 2's up here. Remove all of those. So again, you've got a few options. Oh, what about in the middle? 2's can't be in these, or that one, or that one. So these 2's are in one of those. Okay. Again, not real helpful. These can't be 2's. All right, 1, 2, 3, 4. 5 can't be in any of those because of this 5. So there's a 5 over here. 5 can't be in those, so 5 is over that side. The 5's down here. Okay. 5. We can't have a 5 there or here. So these 2, this one sees the 5 in the column, and this one sees it by knight's move. So these can't be, this one can't be 5 because of that. This one can't be 5 because of this 5. So we know there's a 5 down here, which puts a 5 in the middle, and it can't be in the middle because of the 5 there seeing it by knight's move. So there's 5's in one of those 2. 6. Okay, 6's has to be down here. Can't be there. Can't be there. This is a 6, which gives us the 2, which gives us the 5. There we go. Now we're getting somewhere. Now there's a 2 up here. Can't be there. So there's a 2 in one of those. These are what? 1, 4, 7, 8, and 9. These can't be 7's because of the 7 there. These can't be 8's. This one can't be a 1. This can't be a 7. Oh, and this can't be a 7. So the 7's there. There's an 8 down here. This one can't be an 8. Oh, these can't be 4's. That gives us a 1, 9 pair. This is not 1 or 9. We have a 4, 8 pair now. And this one can't be 4. So it's 8, 4, 4. There's a 4 down here, and this one sees that by knight's move. So this is not 4. 4, 4. There's a 4 over here. Can't be that one. So one of these two is a 4. Now I had those two marked as 1s. Is there? Oh, this can't be a 1. Yeah, because there's a 1 down here. So there's a 5 there. These are a 1, 4 pair. This can't be a 5. These are 2, 6, and 7, just by what's left in the box. This can't be a 2. None of these can be 2s. So the 2 here sees both of those. The 2 over there sees that one. So there's a 2 here. Okay. So what's left across here? 1, 4, and 9, I think. Is there any issues with any of this? One can't be a 4. So the 4 is over here. So that gives us 1 and 4. This is not 4. So we have a 1, 9 pair up there now. What's left in the box here? 1, 2, 8, 9. These can't be 2 or 8. So they're 1, 9, which is going to give us a 4 over there. These are not 1 or 9. So it's a 2, 8 pair. So what about over here? These are 1, 5, and 9, I believe. This one can't be 1 because the 1 there. But I think this can be... Oh, the 9 here gives us 1 and 9 there. But I don't see a 1 or a 9 looking at either of those. A 5 or a 9, 1, 5, 9, 1, 9. Don't think so. 2, 8. Oh, the 8 here is looking at the 2, 8 there. 2, 8. This is not 2. It gives us a 6, 7 pair. So this is a 2. 6, 7 pair. So up here we've got 3, 4, and 8. This one can't be 3 or 4. It's an 8. The 4 here is looking up there. So 3 and 4. These are 5, 6, and 7. This one can't be 5 or 7 because of these. So it's 6, 5, and 7 there. Don't see anything. Okay. These are 5, 7, and 9. This can't be 5 because of that 5. This one can't be 7. There's a 7 down here. There's a 2 over here. This is not a 2. This is not a 3. Okay, so where do we look now? We know there's a 5 in one of these. There's a 5 in one of those. Okay, this column needs 1, 5, 8, and 9. These can't be 1s down here. This one can't be a 5 because of that 5. This can't be a 5. So these are an 8, 9 pair, which gives us 1 and 5 up here, and the 1 sees that one. So 5 and 1. The 1 is going to give us 1 and 9. This is not a 9 now. This 8, 9 pair here is interesting because this one sees that cell in the row and that cell by knight's move. And this one sees that one in the row and that cell by knight's move. So you can actually remove 8 and 9 from both of those cells, which gives us 3 and 2, 4, 9, 5, 7, 9. These are 2, 3, 6, and 8. These are not 2. These are not 3. That one's not a 3. Gives us the 3 there. The 8. That can't be an 8 there. So there's an 8 up here, which means there has to be an 8 in one of these two, and this one sees that 8 by knight's move, so there's an 8 there. These are 2, 6, and 7. This one sees a 7 here. There's a 7 at the top, which means this is 5 and 7. 2, 6. Does anyone else see a 6? Nope. Nope. Okay. So 2, 6, and 7. Oh, the 6 down here. Yeah. 2, 7, 6. Now we need 5, I think. 5. Yep. These are 3 and 7. And one of them must see, yep, a 3. There we go. 7, 3. That 7 gives us the 6 and the 7. This is an 8 or a 9 to finish the row. This row needs 6, 8, or 9. The 5 up here, that's a 9. 1, 9. It helps if I can type correctly. This is not a 9, so we get a 6, 8 pair up here. Oh, the 6 there. 8, 2, 6. This is not a 6. This is a 6. And now we have, oh no, a deadly pattern, except there's a 9 here. Let's seize that by Knight's Move, and there we go. That often happens in a Knight's Move puzzle where you end up with a deadly pattern, and then there's something looking at it that fixes it. So there you go. That was the chess puzzle. And so we got our password for the next one. It's the jewels, which was the 2 and the 5, and that's for the arrow puzzle that we already did. And then we also need to have, oh, that was the wrong thing to click. We also need to have our, here we go. We also need to have the little statue bust thing here, which is going to be a 4, it looks like. That's a 4. So let's add that to our notes. Bust equals 4. All right, and now we can move on to the Thermo puzzle, which we already know the password for, but that's okay. We've made it almost all the way around now. All right, so Thermo, we know the password is Mercury. Here we go. This is the Thermo. Now, I did it in the backwards order. I think a lot of people probably went to the Thermo first. And that's perfectly fine. You can go in whatever order you want. It doesn't really matter. And that was kind of the goal, was I wanted this to be, you know, not simple. It's definitely not easy per se, but doable, right? Not crazy hard. And so I tried to make it, you know, you can go either direction. If you can't figure out a clue, you go the other way. Now, if you get stuck on 2 of them, you might just be stuck. There's only so much we can do. But I didn't want it to be first puzzle, I can't get the clue. Can't do anything else. I'm sure there are some people stuck on the first puzzle, but hopefully people who are familiar with puzzle hunts at least got through the first couple puzzles. Anyways, there is a thing to note here. Now this is, you'll notice it's a house shape. Now a house, that sounds familiar, right? Didn't we have a house at the first puzzle? Let's go back and look at our museum entrance. Look at that, there's a house. Now this would be easier to notice probably. Man, everything's really blown out on my screen. I don't know why there's so much light. Hold on, let me adjust this. The sun is just really bright today, coming in those windows. Is that better? I don't know if that's any better. I don't want to just get rid of all of the light. That's with the curtains. There's that much light coming through, even with the curtains. All right, my face is just gonna be white. Oh well. All right, so we have this house here. Now, it would be easier to notice if you came straight to the Thermo, probably, through the lobby to the Thermo. But one thing you needed to know, and this is something that's not uncommon in puzzle hunts, is this is a house. And you need to put that house digit, which was a 5, right up here in that same location. So let's open up the Thermo puzzle, and we're going to put a 5 in there. There we go. That's our 5 from the house. Now, let's see. What can we do? So thermometer puzzles, we know, let's see, 1, 2, 3, 4, 5, 6, 7. So I'm going to go ahead and put in our options here. It's going to be the same on the other side. Okay. That's good. Now, could this be a 7? That's the question, right? First question, could this be a 7? Well, if that's a 7, these both would have to be 6s. So clearly that can't be a 7. Now, the other thing is, could this be... what's the question? This was one of the first puzzles I made for this puzzle hunt, actually. So we'll see if I can remember how to do this. This is also 7 long, so we can do the same thing. Yep, this is what we need to do. And now you'll note there's 3, 4, 5 triple here, so this has to be a 6 and a 7, an 8, and a 9. And the 7, 8, and 9 down below gives us a 6 there, which forces 5, 4, 3, 2, 1. These are not 3, this is not 4, 5, 6. This is not 2, this is not 1. There we go. So, now where can you put a 1 in box 5? The only place you can put it is right there. The only place you can put a 9 in box 5 is right there. So we get a 1 and a 9 right there. This has to be smaller than 5. It can't be a 4 or a 3. So it's a 1 or a 2. 8, 7, 6, 5. Okay, so these are all right, we can fill these in 2, 3, 3, 4, 4, 5. Oh, but we can't do 4. Hold on. That's I don't think that was right. This can be up to 8. This can be as little as 2. We can't use 6 or 7. So 2, 3, 4, 5, 8. We have 5 digits. So yeah, you can only put 2, 5, 8. It would be like this normally, right? But the 4 here gives us 5 and 8, which gives us 4, 3, 2. This is a 5, 6, 7, 8, 9. There we go. So what we need to do, this is a 3, this is a 2, this is a 4, this is a 3. So there we go. We've got a lot of digits already. This has to be less than 7. It can't be 5 or 6 or 4. So it has to be 1, 2, or 3. Now, let's look at these here. So this is at least 4, because we've got 1, 2, and 3 in the row already. 4, 5, 6, 7. It could be as much as 8. It can't be 9. So we get those as options here. Over here, same kind of deal. 1, 2, 3. So this has to be at least 4, 5, 6, 7. Now this one could be up to 9, but we can't have an 8 because of here. So 9, this one could be a 7, but again, it can't be an 8. So this could be 5 or 6. This could be 4 or 5. But look, 4, 5 pair gives us 6, 7, 9. That 7 is going to give us 6, 5, 4, which gives us 5. This is 1. This is a 7 or an 8, but there's an 8 up above. So 7, 8, type correctly. 3, 7, and 9. These are 4, 5, and 6. And these are 1, 2, and 8. This can't be 4, 6. This can't be 5 or 6. 5, 6. We do that. This one can't be 3. Can we get any of those? Nope. But now we've got 5 and 7, and that 5 up to the right is going to fix that one for us. These are 3 and 4, and these are 1 and 2, and they have to be in that order because of the Thermo. These up here are 6, 7, 8, and 9. So this one can't be 6 or 7. This can't be 6 or 9, and this one can't be 8 or 9. So we get that for our order, but the 8 here tells us that's a 9. That gives us a 7 down there. 6, 8. We also could have got that from the 7 over here. That 7 means these are not 7s. These are 1, 2, 8, 9. This one can't be 9. This one can't be 8. 1, 2, 3, and 7, and this one can't be 7, so we get a 7 over here. These are 4, 6, 8, and 9. These can't be 6. This one also can't be 6. So we get a 6 there. This can't be 8 or 4. That's a 9. These are not 9s. This is an 8 now because there's a 1, 2 pair. The 9 gives us the 3 and the 9 down here. These are not 9s. They're 4, 8. We can get rid of those. 1, 2, 3 triple puts the 9 there. And then we'll look up here. 1, 2, 3, 7. This can't be 1 or 2. These are 1, 2, and 4, I believe. This one can't be 2. This one can't be 7. All right, let's look here. 1, 2, 8, and 9. This can't be 1, 8, or 9. So it's 2. There we go. This is not 2. This one is not 8 or 9, so it's a 1. That's 8, 9. That gives us a 1, 2 here. The 1, 2 pair gives us the 3 there. 1, 2 pairs here. So these are not 1s from the 1 there. The 2 C's there. 3, 1, 2, 4, 7. Yep, that looks good. Okay. Over here we've got the 1, 2 pairs. So then 3, 4, 5, 8 are our options. This can't be 5. This can't be 3, 5, or 8, so it's a 4. This can't be 8. The 4 gives us 8, 4. The 8 gives us the 3 and the 5. The 3 is going to give us the 4 and the 3 here. That 4 will give us 1, 7, 2, 4. And now we just have to fill in the rest of the cells here. This is 6. This one is 8. And then we have the 1 here gives us 2 and 1 and 2 and 1 and 2 and 1. Looks good to me. There you go. That's the Thermo puzzle. And so what was our shape? Oh, we had this Salvador Dali melting clock thing. And it's in row 2, column 3, which is a 2. So let's go back to our notes and say Dali equals 2. All right, I'm jumping in here from the future because I just realized I did not explain the clue going from the Thermo to the chess room, and I know some people had some trouble with that one, so I want to make sure I explain that here. So let's go back over here. So we have, let's zoom in. So the clue to the chess room is shrubbery without echo. Now, some people were trying some things like they were using Monty Python and the shrubbery, and some people thought without echo. They were kind of doing like a cryptic crossword clue where that means you take out the E, and it wasn't anything like that. It was really just almost simpler than that, I guess. The shrubbery is these bushes outside the house. Let's go back to our solved grid. There we go. So it's these bushes here, and without echo just means don't use the repeat. So the 5, 6 and the 5, 6 are repeated. That would be the echo. And so you're just using the 9, 7, 4, 8. And that's it. It's the shrubs, the bushes, without the repetition or echo. So 9, 7, 4, 8. So there you go. Now, back to the special collection. Or the lobby, sorry. We need to go to the access to the special collection. This was 569361 for the lobby. So for the special collection, let's zoom in a little bit. You'll notice we have 8 symbols there, okay? 8 symbols. We have all of them except for this vase here. But we also have the scream, and the scream is not on here. So, this takes a little bit of just kind of thinking about what makes sense, maybe a little bit of guessing. But so one thing you could do, of course, is fill in the 7 digits we have and just guess digits for the vase, and you would get there. And that's I think that's a valid strategy. It's less, I don't know. Whatever. It works. It's just a little more brute force. But the other thing you could do is you could say, well, we use there's no repeats in here except for the 5, right? The house and the pallet were both 5. But we used the house already in that other grid. We haven't used any of the rest of them. So maybe the house is done. Maybe we've used that one up, okay? So now we've got 8, 6, 1, 7, 5, 9, 4, 2. We've got every digit except for the 3. Perhaps the vase could be the missing digit. And in fact, that's the correct answer. So we're going to have, let's put our note in here. So we've got, I'm going to go down to the next line. We're going to write out our code. So we've got the modern art is 7. Then we've got the brush is 1. Then the bust is 4. Vitruvian is 9. Okay, and then on the other door, we have the apple is 6. We're going to say 3 for the vase. The palette is a 5, and Dolly is a 2. So there is our password, we think, for the special collection. So let's go back and try and open the special collection. Password is 71496352, and we're correct. Okay, now this final puzzle is something called a link-a-pix. It's the only one that's not a Sudoku. You may notice in the letter at the beginning, it mentioned that the artwork was in the special collection on loan from the pencil puzzle across town. So it's not a Sudoku. It's in the Sudoku Museum, but it's a special collection on loan from the Pencil Puzzle Museum. And so the way a link-a-pix works is you need to first we need to put the numbers in the grid in place of the symbols. And then we're going to connect the dots essentially. So if you have 2 5s, you're going to draw a snake that connects the 2 5s, and it has to be 5 cells long. Now we don't have sometimes with snakes they can't touch themselves or orthogonally. There's none of those rules. It can go, if you had a 6 cell, you could go 1, 2, 3, go up 1 and back 3, and it would be fine. So it's kind of going to make like a 2 by 3 shape that way, and that's fine. But we're going to fill all these in, and then we're going to see what we get. So the first step, of course, is just to translate all of the numbers into the grid in place of the shapes. So I'm going to do that quick. I'll be right back. All right, so here we go. I've got all the digits in here. I think this should be correct, hopefully. And now we just have to kind of figure out how to solve this. So I'm going to kind of just use colors to differentiate the different numbers. I don't know if I'll be consistent throughout the whole grid, but just locally at least. And hopefully that'll help. So this 4 here, right? What can it connect to? Well, it can't connect to this one. It can, but the problem is there's no way to make a 4 cell, 1, 2, 3, 4. You can't do it in 4 cells. Now you can connect to either one of these, but this one obviously has to come out this way. It can't go anywhere else. Now it can't connect to here because it would only be 3. And if you go over here and down, it's going to be 5. So it has to come across to there. And so now this one, where there's no other 4 it can get to but that one. Now, it could do something like this, and you could leave an empty space, and the rules didn't say you have to fill the grid. You'll find, as you solve it, that you do have to fill the grid. And you could figure that out if you did the math, added all the numbers up, divide by how big it is, you're going to find that the grid will be filled. So I'm going to go ahead and do it this way. Now you also are going to figure that out because like this 6, 1, 2, 3, 4, 5, 6, it can't get down to this 6. So where can this 6 connect to? It has to connect to that 6. And the only way it can do that is to go up and through here. So that would also give you the order of the 4 there. So that works as well. Now let's see. How about this 7? It has to come up and out this way. 2, 3, 4. Where could it possibly connect to? It has to connect to here. So it's 1, 2, 3, 4, 5, 6, 7. Okay, so that's fine. This 7 has to come out this way. What can it connect to? 3, 4, 5, 6. It can connect to this 7. 1, 2, 3, 4, 5, 6. It can connect to this one. But 1, 2, 3, 4, 5. Yeah, and this 7 could go. So there's a lot of ways the 7s could connect up here. So let's not do 7s yet. How about this 8? Where can that 8 go? The 8. It's got to go down here. 1, 2, 3, 4, 5, 6, 7, 8. It could get down to this 8, or it could connect to this 8. So one of those two 8s, but it pushes the 7 farther down, which then pushes the 8 farther down. Okay. Now, is there a way? 1, 2, 3, 4. We're already at 5, 6, 7. There's no way to get 8 cells. So 1, 2, 3, 4, 5, 6, 7. You can't get to that one in 8. There's no way to do it. So it has to go over to this one. And so now the yellow is forced over here, 2, 3, 4, 5, and it could go up or down. These 2s are obviously connected to each other. There's a bunch of spots in the grid actually where we can go through and just connect the 2s because they don't have any other option other than to just be next to each other. And actually we could fill in these 1s as well because they're their own snake, right? Actually, here, I'm going to do the 1s in black. Let's do that. 1s in black. There's probably some more. If I find others, I'll grab them as we go along. That's fine. Okay, so back up here. Let's see. So our 7 now, this 7, it can't come down and go anywhere. So it's got to come out this way, right? Now, what could it connect to? It could come down to this 7. It could go straight across. It can't get to this 7 down here, though. Okay. What about this 5? Let's see. I'm going to use yellow. Let's see. 5 has to come down this way. That's the only thing it can do, actually, is connect to there. This 5 has to come out this way. What could it possibly connect to? It's got to be that 5, which then forces the 7 across to there. Now, this 4 has to come out. Now, it could go 2, 3, 4. Yeah, I can't get to the 4 down here. That would be 5 cells. So it's got to connect to that one. This 5 has nowhere to go but across to that 5. The 3s have to connect to each other. Now, knowing that we have to fill the grid, you could say it has to go there, but we won't use that knowledge quite yet. I don't think you need that in order to finish the puzzle. Now, here's something interesting. This 7 here, how could it connect to that 7? It would have to go 2, 3, or 2, 3, right? Somewhere it would be 1, 2, 3, 4, 5, 6, 7. You could do that, but then where is this yellow 7 going to connect to? It can't get. You're blocking that 7 down there, so it can't do that. So the yellow has to connect up here, is essentially what that means. And so this 7 here has to then connect to this one. 1, 2, 3, 4, 5, 6, 7. It has to kind of snake its way down since it is a snake. How about that? The 5 here is coming down. It can't connect to a 5 anywhere over here, so it's got to go straight down to that 5. And now this 6 has to come down. Where could it go? It's got a few options, so we don't know that one yet. Let's see, the 9 up here, 2, 3. Where is a 9? It could 3, 4, 5, 6, 7, 8. It could connect to this 9 down here, but this 5 would be completely blocked in then. And that 5 has to go somewhere. So the 9 has to keep going. So the only way it can get to a 9 is over here. But that's 1, 2, 3, 4, 5, 6. That's only 7 cells. So in order to make it 9, it needs to do a little jog down and over and back up. And now that pushes the 5 down. And it's got to connect to this 5. It's the only place it can connect. Let's see. Let's go. The 4 here has to come down somehow. 3, 4. It can't get to this 4. It would be 5 cells. So it's got to connect to that 4. Again, we don't know which one of these 2 it uses. This 4 can go to either of these at this point. But this 4 right here, where can it connect to? 3. You can't do 4 cells and get to there. It's just not possible. And it can't reach down to this 4, so it has to connect to that one. But we don't really know where it goes. Now this 4 has to come down to there. That pushes this 5 down to that 5. Oh, we got another 1 here. The 7 here has to connect to this 7. But that's only 5 cells there. We can't go up and over, it'd be too long. So the only way we can do it is if we go 1, 2, 3, 4, 5, 6, 7 down there. And now this 4 has to come out, but which 4 does it connect to? Well, if we connect to there, then this 4 is blocked. So it's got to connect up there, and these 4s connect to each other. This 7 now has to come out this way somehow. It has to get down to this 7, and the only way to get there is the most direct route in 7 cells. These 5s connect. These 5s connect. Got another 1. The 7 here has to come down and out. This 8 has to come down, which pushes the 7 even farther, and it has to turn and get out here, which then means that the 8 has to turn. But we can't connect here. That would only be 4 cells. So we've got to go 3, 4, 5, 6, 7, 8, which then means that the yellow has to come down here. 1, 2, 3, 4, 5, 6, 7. Very good. Now this 9 needs to connect to one of the 9s, but it can't connect yet. It's got to come down here and turn. We're not sure where it goes from there, so we'll just do that for now. This 5, 2, 3, 4, 5, it's got to go out that way. This 9, let's see, it could connect to a few different places, but this 9 up here, let's come back up to this 9. This one has to connect to here, right? Or, well, one of these two. But for it to come down and connect to this 9, it would block off this other 9. But either way, it's got to come down through here somehow, right? Now, where's it going to go? Where's it going to go? So that's 3. If we just go directly, 4, 5, 6, 7. So we need to get 2 more cells somewhere. We could pick them up in here. You know, it could do something like that. We could pick them up over here. If it did a little jog at the beginning, it could get a couple cells over here. So we don't really know where that goes yet. How about these 6s here? Well, this 3 has to connect to this 3, right? We know that. So this 6 has to come out here. Now, what does that do to this 9? Because we know this one above it is the pink one, right? This is the pink 9. So this red 9 has to come out, and it's got to connect to this one somehow, but it can't go down under the 6 anymore. So it has to come up and over, which then means the pink one comes up here. Now the red, 1, 2, 3, 4, 5, 6, 7. So we need to get 2 more. So it's got to come up and do a little jog up there. Like that, which forces the pink here. 1, 2, 3, 4, 5, 6, 7. So it's got to get 2 more here. And that's going to force our orange 4. It forces our gray 4. And that forces, I don't remember what color the 3s were. Was it that color? Sure, it was that color. Now our 6 is down here. We've got 1, 2, 3, 4. So it's got to do a little 3, 4, 5, 6. It's got to do a little jog up there. And it can't connect to any other 6 because, I mean, it would have to come down to here, and then it would block that 6. So it's got to go that way. This 6 has to connect to here now. There's a few ways it could do it. It could come down here and up. It could come over the top, but it has to go there. These 3s have to connect somehow. Let's see. Let's make the 9 orange. It has to come down to here. So 2, 3, 4, 5, 6, 7, 8. There's a few ways we could do all that. So we're not sure what to do with that one yet. But all right. How about back up on the left over here? This 5 needs to connect somewhere. Has to go to that 5. This 5 can't get over to here. It'd be 6 cells. So it has to go straight down to that 5. This 6, it's got to come up. It's got to connect to there somehow. But we're not entirely sure how yet. But this 5 needs to come up and connect to that, which is going to give us the rest of that 6. Now the 4 has to come down to this 4 like that. The blue, the 9 has to get out this way, which pushes this 4 down. It's got to connect to there, but we don't know which one of these cells it uses yet. These 3s have to connect to each other. Where can this 8 go? It's got to come up and out somehow, right? It could do a little jog over and then up, but it's got to come up and out here somehow, which is going to push this 5. Let's do, we need a different color, don't we? Let's use green. How about for the 5? There we go. So the 8, 3, 4, 5, 6, 7. It can't connect to this one. There's no way to make the math work. It's going to be 7 or 9 cells. So the only 8 it can really connect to is up here. 1, 2, 3, 4, 5, 6. So it's got to do somewhere in here an extra jog over. But the 6 has to come straight up through. So now the only way the 8 can jog over is right there. So the 6 has to do that. 2, 3, 4. Now, theoretically, it could connect over here, but then this 6 has... Oh, this 6 can still connect to there, can't it? Yep, so I better not do that yet, but the 6 goes here. This 5 has got to come straight down to the 5 there. It's the only 5 it can connect to. This 9 comes out this way. All right, let's look at, what about this 4 down here? The only thing it can connect to is that one. Now this 9 has to somehow connect to another 9. It's got to be this one up here. Is that pink? I think maybe. Let's make it orange. So it's got to connect to there. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's got to do that. It's got to come down here and up and around that way. It's the only way that works. And then this 8's got to come out of there somehow. Oh, wait. I didn't want to use orange. I just did orange. Let's do green again. 8. It's got to come out. And it can't connect to this 8 because there's no way to get enough cells. So it's got to connect to the 8 down here. 1, 2, 3, 4, 6, 7, 8. So it's got to go, somehow kind of fairly directly down there. But we don't know quite where it goes yet. These 3s have to connect, which then means this 8 comes out this way. 1, 2, 3, 4, 5, 6, 7, 8. That's 8 there. Good. Now the 6 has to connect over here. There's a few different ways it could do that, but somehow it has to come across here, which means these 5s aren't going to be able to connect to each other because that'll only be 3 cells. So this 5 has to go a different way. This 5 has to come down this way. Where could it connect? It's got to come straight across to there, which means this 5 has to come over and connect to one of these 5s. That pushes the 7 all the way out here to there. And now this 5 has to... Oh, well, it could connect there. That's right. We don't know yet. But this 5 has to come out this way. We definitely know that. 3, it could come up and connect to there. It could go straight across to this 5. It can't go down. And in fact, I think this 5 down here, the only thing it can connect to is that 5. It makes these 7s connect. It makes these 8s connect. This 7 has to come up and out. The 6 is going to have to connect to that 6. It can't get up to this one. There's no... Once you get up to here, you can't... there's no way to come out and back in as a snake. So it has to do kind of a zigzag shape here. Sort of like a backwards S. Or a Z, maybe. Something. Let's see. So this 7 here, let's use red. This 7 has to come out. It's got to somehow connect to one of these, right? Oh, but there's the orange one down here. But if it comes over and down, it's going to be 6. So these 2 can't connect to each other. And if this one connects down here, it's going to block this 7 off. So this one has to connect up there. Let's do purple instead. There we go. And so the orange 7 has to connect to here. 1, 2, 3, 4, 5, 6, 7. It's got to go that way. So now the purple one has to come up, somehow connect to there. But our 8 needs to connect to the green. These 6s need to connect to each other. Let's do light gray for the 6s. So the only real way to make all that fit is to do the 6s like that, the 7s like that, and our green 8 comes down this way. Any other way you do it, there's just not going to work, basically. You can try it, but that's the only way it works. So we get the 4 finished off there. This 6 has to come out. We don't know that it's blue, actually, but let's do light gray for now. It could connect to there, but we don't know. But it has to come out this far. 2, 3, 4. Actually, it could connect to the yellow, couldn't it? So we don't know that yet. All right, so let's not do that. This 6 here has to do this little jog up and over. We get the 3s connected. Where can this 5 connect to? It can only connect to that 5. Let's do that in a different color, I guess. Did I use 2 different colors down here? I think I did. That connects there. Yeah. Okay. There we go. Coloring a puzzle is not great when you're colorblind. This 6 has to come out somehow. Where can it go? Where can it go? It has to come down here. That's the only place it can go. Which pushes this 9 out this way. Now I think this 9, 2, 3, 4, 5, 6, 7, 8, 9. Yep, that's the only way you can do it. It has to wrap around itself and fit in there. The 3s go in here. Now the 6 has to pick up these extra 2 there. Let's see. The 4. The 4 down here has to connect to that 4. That's the only place it can. Now this 4 has to connect to this 4, but we don't know which of these 2 cells it uses yet. These 3s have to connect to each other. Okay, we're closing in now. This 9 has to somehow get up here. Now, if it comes through and connects to that 9, then where is this 9 going to go? And this 9, they're trapped. So it doesn't have that option. It can't go up there. It has to connect to this 9. So 2, 3, 4, 5, 6, 7, 8, 9. It could do something like that, weaving up there, but we don't really know that yet. But what we do know is this 5 has to connect to the 5 down there. So now we do know how the 9 goes. 2, 3, 4, 5, 6, 7. One of these 2 gets it to the 9. But this other 9, let's make it orange maybe? Purple. Has to somehow get out of here, which is going to force this 9. So the purple 9, 1, 2, 3, 4, 5, 6, 7. It could connect. It could be the orange one here. If it's not, 7, where's it going to connect? 8, 9, it's going to be 10 to get, so it has to connect to there. And now these 2 9s have to connect to each other somehow. So this one has to come up and out, which means this end has to come up and out that way. 2, 3, 4, 5, 6. And then there's a few ways they can connect from there. The 8 has to come out this way. It's got to connect to that 8, but we don't quite know where it goes yet. This 6, where can that 6 connect to? Let's make it, what should we do? Light gray? Light gray. This 6, 1, 2, 3, it could go straight up, right? It could go, why did we have this 6 coming out that way? Is that forced to come up that way? Couldn't it come out this way? I think it could. All right, let's go back because we were here. This 6. So, okay, we could do the math here and figure it out, but we're going to have to fill every cell in this section here. You can just trust me. There's 3 sets of 6. There's the 8 and there's the 9. So that's 18 and 17 is 20, 35. So 35 cells. We've used 1, 2, 3. We've used 6 8s, 6 9s. That's 12, 13, 14, 15, 16, 17. So we need 8. Yeah, so we're going to fill in the rest of the grid. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I think the math works out. We're going to fill the rest of the space in here. And so what that means, what does that mean? What does that mean? The orange. So what could possibly be down here? Nothing can come down in here and back out. So it's got to be part of this 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's got to do that. Now the 8. The 8, right. So the 6 does have to go out the top because this 8 has to somehow connect. It can't come up and around this way or anything. It has to come through here somehow to connect to the other 8. So this 6 is forced to come up this way. And we know this is 8 then. 3, 4, 5, 6. It could have those two, or it could have 2, 3, 4, 5, 6. 2, 3, 4. This is 6. We need 2 more. So somehow the snake has to... It can't go here because it doesn't work as a snake. It's got to do those two. That's the only way it works. So this 6 has to come up here. It's going to have to connect to that 6. Got to go that way. And so now... I must have done something wrong. What did I do wrong? Interesting. Oh. No, it can't do that. Go back. I did something wrong. Okay. Because this 8 has to come out here, doesn't it? Let's use a different color for that 8 because of the 5 over here. 3, 4, 5, 6, 7, 8. That's 8. Okay, so the 6 has to go this way. So the other 8 now 2. It doesn't have to have that one. That's the problem. 1, 2, 3, 4, 5, 6, 7, 8. That was the problem, is I colored that cell and it shouldn't have had that one. Okay. That makes more sense now. Let's see. Let's do orange for this 6. Oh, this gray 6 now has to come up here. 2, 3. There's no way to get connected to one of these in 6, so it has to actually go straight up. And then this one is 1, 2, 3, 4, 5, 6. Okay, so you could play around with that a little more without knowing that you have to fill all those cells. You can count and figure out you have to fill all those cells. But if you play with it, there's no other way to do it anyways. So there you go. All right, so this 5 here, I think was purple. It has to connect to this 5 now, because before we thought it could connect to here potentially, but that one's up there with the yellow. So that's the 5 over there. This 4 has to come out here. Now, it could come over there. It could also turn up and come right back to this 4. But if it did that, this one would be trapped. So it has to do this, which means these have to connect somehow. That pushes the 8 out this way. Now, where can the 8 go? It's got to come down to here. 2, 3, 4, 5, 6, 7. One of those 2 is in. These 7s here have to connect. 1, 2, 3, 4, 5, 6, 7. It's got to do that, which forces the 8 to go down there, which forces the 4 to go this way, and forces the other 4 to go that way. 8 comes up. It's got to connect to here. It can do that. This 9 now comes up here. 1, 2, 3, 4. It's got to connect to one of these 9s. 1, 2, 3, 4, 5, 6, 7, 8, 9. It could connect to there. Could it connect to the other? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, it could connect to that one as well. So we don't know which one of those it connects to. This 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It could connect to there. 6, 7, 8, 9. It could connect to there. So somehow these 9s have to connect to each other. And I think, so knowing that we have to fill, so now it would be easy to do the math here and count and find we have to fill this portion of the grid over here, right? If the gray is the only one that can get to this cell at this point. So the snake has to go 1, 2, 3, 4. Let's see. Let's not make it gray because the 7 is gray. Oh. 7 is gray. So it's got to do this. 1, 2, 3, 4, 5. 6, 7, 8. Now the only one that can get into this cell now is either the pink, or if this is orange, it could go this way, right? But It can't be the yellow. The yellow can't get into there, essentially, is what I'm saying. If that makes sense. So the orange would have to come out this way. 2, 3. Now, now it can't connect to the yellow. 2, 3, 4, 5, 6, 7. Can it connect to the yellow? Maybe it can. Oh, I know what I need to do. Okay, go back. I got it. Okay, the yellow has to go here now. It's the only way that you can get, because you can't come into here and back out. So it's got to go this way. 1, 2, 3, 4, 5, 6. Now, if it connects, I think there's actually 2 ways these 9s can connect, isn't there? 6, 7, 8, 9. No, it can't. Okay, right. That's what you do. Okay, perfect. Yes. So for this is 4, 5, 6. For it to connect to this 9, it has to go 7, 8, 9. And now there's no way for the pink one to get these other cells over here. So that's the key thing, is this one turns up here, and now same deal. This one can only be picked up by the yellow. 1, 2, 3, 4, 5, 6, 7, 8, 9. I thought there was only one way to do it, but there you go. So that is the solution to the Linkopix. Now, several people sent me something just like this, and they were so close. You almost got it, but the thing about a Linkopix, the reason it's called a Linkopix is it makes a picture when you're done. Now, this does not look like much of a picture. It's very abstract, I guess, right? An abstract picture, maybe. But if we go back to the letter, what did the letter say? Do we remember what the letter said? The letter said, first of all, it said, a priceless trophy was stolen from me several months ago. Be sure to cover up any artist's tools you need to use. So what would be artist's tools? If you remember, we had the scream, the house, the apple, the brush, the modern art, the palette, the true, and the bust of the dolly. So the 2 that are artist tools are the brush and the palette, which is the 1 and the 5. So we've already got the 1s in black. Let's make the 5s black as well and see if that gives us a picture. It might start to take shape here. 5. There's a 5 across here. There's a 5 down here. You should start to see a picture emerge here. In the grid, we get a 5 all the way down there. And there you go. So if you just look at the black, you might have to kind of step back a little bit to see it. But if you just look at the black, that is a trophy with a number 1 in the middle. So there is the final answer. That is the priceless trophy that was stolen that you're trying to recover from the special collection in the middle of the museum. Good work if you got that. If you didn't, that's all right. I hope you enjoyed what you were able to try, and I hope you enjoyed the puzzles and everything, even if you weren't able to solve it all. Let me know what you thought. If you thought this was absolutely ridiculous, there's no way anybody could have ever gotten it, leave me a comment down below. I'd be interested to know that, for future puzzle hunts. The idea with a puzzle hunt is not to just stump everybody, right? Like, I'm not trying to make something that's so hard that no one could ever solve it. Like, that's no fun. But you want it to be a little bit of a challenge too, so that it's fun to solve. So knowing how difficult to make things is always kind of tricky. So I appreciate feedback on that. If you thought it was too hard, too easy, hopefully, my goal generally with the clues is they're not obvious at first, hopefully. I mean, like HG being Mercury, that one probably wasn't too far out there. Hopefully not too obvious, but once you know the answer, you kind of say, oh yeah, okay, right? That's sort of my theory behind setting these puzzles a lot of times is I want it to seem obvious in retrospect, but not be obvious from the one side, if that makes sense. What I don't really like is when a clue, if somebody here's the answer to a clue and they go, well, how was I ever supposed to figure that out? So I'm sure there'll be some of that, but hopefully not most of you feel that way. The testers didn't feel that way, but anyways, hope you guys enjoyed this. This is going to be a crazy long video, but Yeah, there you go. That's the solution to my museum heist puzzle hunt, in case anybody is still watching this far along in the video. We'll see you guys again soon with a more normal, shorter puzzle. Thanks. Bye.